Okay, very good. So I just keep going, and people can interrupt. Yes, so please, if you can interrupt, please feel free to interrupt me at any time. Okay. All right. So this is basically the data entry part. On a daily basis, the entrepreneur would enter the excuse me, the sales. So this is essentially what the app would do. It says, first of all, it will ask the question, was your business operating today? And then if the business was operating today, how much money did you end up collecting, right? So that's essentially what this asks, very, very simple. And then on a bi-weekly basis, what we ask them are information about the product. So what exactly do I mean by that? These would include questions like, what is your most popular product or service? First of all, trying to get information on that. Then essentially asking how much of that product or service did you sell? Asking the price that they charge for the product or service. And then essentially trying to get the cost associated with that product, and then trying to compute the profits based off those costs, right? So that way the app can measure things like profits, etc., or profit margins, etc. Okay. Also, on a bi-weekly basis, we got the entrepreneurs to give us data about their customers. So we asked them, for example, things like, how many regular customers, came to the store, and what did these regular customers essentially end up buying, and then what other kinds of stores, right? So what other kinds of customers, irregular customers, for example. So different types of customer groups, trying to figure out what their sizes are, how frequently they come to the store, etc. Okay. So those are the kinds of information that the app would take in. By the way, I'm not spending too much time on the app itself because because of not having too much time to spend on walking you through the design of the app per se. But suffice to say that this app was developed specifically for this purpose. So this is not an off-the-shelf app. So it was created in a way to make it very simple and intuitive for the entrepreneur to interact with. Okay. These are sort of some of the screens that the entrepreneur encounters with the app. There's obviously a login screen. They can pick a language. Some of them actually speak English, but most of them speak Kinyarwanda. So the app also has to work in the language. There is a place where they put in their own information, which is the information of the owner or the entrepreneur, and finally the business information, which I've already shown you a little bit about. Okay, so those are the screens that constitute the input from the entrepreneur. Okay, now it's the output part. Okay, so what it does is it essentially uses takes in all this information and essentially recast that information in a way that might be useful for the entrepreneur. So, for example, in looking at the sales, while the entrepreneur puts in the daily sales, what the app then turns around and does is it creates weekly cumulatives, and then it shows like monthly sales trends. So the app, so the entrepreneur can keep track of whether or not sales are going up, whether they're going down, what's happening with specific products, what's happening to the margins of these products, how are they changing over time, what's happening to their customer base, etc. Right. So these are the things that the app will then inform the entrepreneur about. So here are some of the screenshots. I apologize if this is not very clear to you. This tells you about how the profit margin for the products are changing over time, and the sales of the products are changing over time. It gives you a snapshot of your current month, and it also tells you, what are your top selling products and how are they doing week on week, right? So all these kinds of information are available to the entrepreneur now to interact with the app and take information away from the app to be used for their business. And then we also provide them with monthly reports, which is a consolidated picture of how the business performed in that month. Okay, so there's sales-related information that we provide in this report, and then we provide also product and customer-based information. But these are all now monthly reports that are provided to the entrepreneurs. Okay. So this was essentially the intervention. So the entrepreneurs in the treatment group went through this process for 6 months. So every day they input the sales numbers. If you're interested in things like compliance, I mean, we have a lot of data, I mean, a lot of results on this, which are there in the paper. So initially, obviously, compliance is not very good, but it sort of ramped up very, very quickly. So we got compliance well over 90% in the study. The other thing is, the things like attrition and dropouts are not very large at all for a study of this size. I think we ended up with close to about 527 of these entrepreneurs, I think, if memory serves me right, who ended up at the end of the end line of the study. Okay, so let me show you some results. Essentially, I want to show you three sets of results. One is sort of the main effects of what we found, which is remember, at the beginning we know the profits and sales of these firms. Then they use the app. Then at the end we again look at the profits and sales. Okay, and so the question is whether the treatment group that had access to the marketing analytics 1.0, did they do better than those in the control group who did not have a similar access? And how did for example, the people in the placebo group do? Okay, then we want to track down. Once I show you the main effects, I would then like to show you a little bit about the mechanism. And in the mechanism, we want to dig into what the individual entrepreneurs' sort of aptitude metrics were, and then finally we'll talk about the individual entrepreneurs' actions. Okay, so those are some of the results that I'd like to share. Okay, so this is what happens to firm profits over time. So you want to think of you essentially you see the treatment group and the control group here over the different time periods, and essentially what ends up happening in the in the months after the intervention is that the treated group does seems to be doing much better than the firms in the control group. So this is for firm profits. We also sort of came up with an index which combined profits and sales. I have the graph for sales, but I don't want to overload you with too many graphs. So we created an index of profit and sales, and you sort of get pretty much the same same result. Okay. So it seems as if just looking at profits and sales, the firms in the treated group were better off than those in the control group. Now, was the improvement specific to certain sizes of these firms? And the answer to that is no. It turns out that regardless of what size the business was, whether it was a small business or a large business, the entire distribution of performance is shifted to the right. So what this graph shows you is the CDF of the performance index of the three groups, which is the treatment group, the control group, and the placebo group. And what you see here is that the frontier for the treatment group is shifted to the right, essentially showing that almost for the entire distribution of size, which in this case is being captured by the sales profit index, that you see an improvement. You see an improvement in the treatment group compared to the control group. Okay. Now we did a bunch of robustness. Obviously, whenever you run a randomized control field experiment, there are lots of questions that people might have about whether the results are robust to a bunch of different things. So I'm not going to go over all of these, but essentially what we looked for or checked or where was the sample balanced, post attrition at the end. I just showed you what the raw data was. What happens when you throw in a bunch of controls? What happens if you deal with when you also take into account firm survival and other issues as well. So not just the intent to treat measure, which is what I showed you, but also the ATT, if you would. What happens when you put in things like attrition bounds? What could be sort of some intermediate measures that you could get data on? And these are customer product related outcomes that you think would potentially improve as a consequence of the having access to information from the app. The other thing that you might be concerned about is, look, if these firms are all sort of located close together, we tried not to make sure that they were not. But if the treatment groups and the control groups were located close together, perhaps the control groups that are closer to the treatment groups suffered due to competition. So that's a check that we did. Then we control for a bunch of other things, which you think you might think is being important as well, right? And so these were both checks on outcomes, but also checks on the process itself. And so these were some of the things that that we looked at. Okay, so now that we have shown that there is an overall effect of the analytics 1.0, you might be sitting there going, well, we know that firms engage in analytics, and perhaps the reason they're doing this is because they expect to see an improvement. So what exactly are we learning that we didn't already know? So obviously the first thing is in terms of the outcomes itself. The fact that sales and profits improve, and they improve by a fair measure. I don't think I've actually given you the size of the effect, but it's I believe profits go up by about 25% roughly in this case. So it is a significant increase in the profits. So you might say, well, that's one thing that you can take away is just the size of the improvement that you see because of the intervention. But I think more importantly, you'd like to try and understand why is it that we are seeing this improvement. And I think thinking about the mechanism perhaps is sort of the more generalizable aspect of these studies. If you want to port this from this scenario to some other scenario, you might want to ask yourself, is the mechanism also portable? Because ultimately, if the mechanism tells us the route by which this happens, if that mechanism is not going to be accessible in a different context or implementation, then one might worry about whether or not you would see a similar kind of an effect. Okay, so we'll spend a little bit of time looking at the mechanism. So we as I said before, there are two types of mechanisms we look at. One is the entrepreneur aptitude, so which is essentially what's happening in the mind of the entrepreneur. And the second is looking at what we can observe, which is in terms of the entrepreneur's actions. Okay, and so we want to try and investigate each of these two routes by which the sales or profit improvement might have occurred. So the first thing we look at is the improvement of the entrepreneur's aptitude, if any, as a consequence of the marketing analytics tool. Okay, so again, as I said before, the reason why we might be able to do this is because of the presence of single decision makers. Okay, and there is theoretical research which suggests that low numeracy could affect the way the individual makes decisions. So if having access to the app and sort of going through this numbers drill every day, every week, every month, somehow that improves the numeracy and the skills of the entrepreneur in just dealing with numbers, then perhaps that could be a potential route by which it ends up influencing what the entrepreneur does. Okay, so our hypothesis going in is that the entrepreneurs become more numerically inclined, which in turn leads them to make better decisions. So we're going to look at two. two broad categories of these. One is just the numerical and reasoning aptitude of these entrepreneurs, and the other is going to be the use of data-driven approaches. Okay. So here's a little bit about different dimensions of entrepreneur aptitude. And I apologize again if you can't see the y-axis on these graphs. So the graphs capture, the bars capture the three groups that we have. So the blue group is the control group, the green group is the treatment group, and the I guess the pinkish bar is the placebo group. So the real interest here is to compare the treatment and control. As you can see, the bars on the placebo group tend to be much bigger. Okay. So on the y-axis here are various tests that these folks undertook. So this one over here, this stands for the cognitive reflection task, or the CRT test. And so essentially, what is the cognitive reflection task? It essentially asks the entrepreneur to go through a bunch of questions, and these questions are, many of us have encountered these questions. They are not necessarily trivial questions. So here is one of them: a bat and a ball cost 110. The bat costs 100 more than the ball. How much does the ball cost? Okay, and so we all know what the answer is, but these are the kinds of questions that we had the entrepreneurs answer. Okay, then we have the digit span test, which essentially tries to get at how many digits, up to how many digits the entrepreneur can remember from as numbers get longer and longer. Okay, so there are many of these tests, Raven's tests for pattern recognition. So a bunch of these tests were undertaken by the entrepreneurs. And so this essentially summarizes, again, the raw data here that we see. And what these data seem to suggest is that the treatment group shows a significant improvement in these metrics as compared to the control group. Now, one of the things you will see is that the first four of these measures, which are the top three in this chart and the bottom left on the chart, those are what you could refer to as objective measures. The last two measures are more the stated measures. So one of the things that you do see is that the stated measure, the difference is a bit more pronounced than the difference in the more objective methods. Okay. So it seems as if one of the routes, which is the aptitude route, does seem to hold in terms of changing the numeracy or the mental math abilities of these entrepreneurs. Now, of course, that by itself is not enough, because unless that then gets translated into actions, it's not going to really help the entrepreneur a whole lot to just get smarter without actually using the smarts for the business. Okay, so the next thing we look at are the entrepreneur actions, and so here also there is a fair bit of literature which seems to suggest that best practices are important driver of growth. And so if we actually see the entrepreneur's actions improving, then there is, it seems reasonable to then believe that this must be a driver of the outcome of improved profits and sales. Okay. So there are two things that we're going to look at. One is we're going to look at straight marketing related activities. And the other is we're going to see whether, having this capability actually has a spillover into other functions that the entrepreneur might also engage in. Okay. So here are sort of the marketing activities we look at, and we look at four of them. Again, I apologize for the y-axis that you may not be able to see. So the four things we look at are, how often they change prices, whether or not they are monitoring their inventory, whether or not they inspect product quality, and whether they add more products, improve their portfolio of products that they offer, etc. Okay. So those are the things that that we look at. And here again, it seems very clear that the treatment group does much better on all four dimensions than the control group does. And again, the placebo group a lot noisier. But if you are open to interpreting the averages, there does seem to be some movement in the placebo group as well. Okay, so it seems as if, as far as marketing activities are concerned, having access to this Analytics 1.0 app does seem to have an influence on these entrepreneurs. Next, we look at spillover into other business activity. So here are some of the things that we noticed. So one of the things that these entrepreneurs got very good at is maintaining written records about what was going on. So here you see a handwritten ledger on daily product-wise revenues and cost information that this entrepreneur was keeping track of. Here was another entrepreneur who was keeping track of all the products and so the inventories of all the products that he or she was carrying. Okay, so now if you look at look at some of these other activities which are non so directly marketing related, and you can think of them as being broadly like accounting or finance related activities. We looked at four of these metrics. So one of the metrics that are relevant to a lot of these small businesses is whether they separate out their home finances from their business finances. Okay, and so what we see is that the treated group seem to be a better job at doing that, although nowhere in anything we told them was this sort of implied in any way, right? And so they seem to be doing that. They also seem to be better at budgeting. Creating future budgets, keeping track of their cash flows, creating income statements and things like that. So they seem to become, with this improved numeracy that they have, seem to have gotten better at also doing activities which are not directly marketing related. Although, remember, the app itself was purely marketing related. The notion of improved numeracy goes beyond just the marketing activities. So it seems to be spilling over into sort of this broader comfort or ease with using numbers, which then spills over into other activities that these firms might be engaging in. Okay, and then we created indices of all these. So if you recall, there were four metrics of. Sorry, I hate doing this, but there were four metrics of marketing activities, and then we have these four metrics of these financial record keeping. So each of these sets of four we created into an overall index to just see whether we can present this in a simpler way. And again, these overall indices show very strong improvement in the treated group compared to the control group. Okay, so overall the performance of the businesses improve, and in terms of the mechanism, it appears as if the aptitude or the numeracy or the skills of the numerical abilities of these entrepreneurs improve, and that seems to be translated into the marketing activities that they engage in, which require this skills in numeracy, as well as non-marketing kinds of numerical tasks that they seem to be engaging. We did a bunch of robustness checks for the mechanism. First of all, the issue was maybe the control group were perhaps not paying as much attention to these various tests that we were giving them compared to the treatment group. So we were able to look at the overall duration of the interview. Did not see a significant difference between the treatment and the control group. As discriminant validity, we also looked at some unrelated tasks that the entrepreneur might have engaged in. And these are things like machine maintenance, process efficiency, things like that. And over here, we see that really there's not much of a change in these things, which are completely sort of removed, if you would, from the activities, right, that are directly relevant to either marketing or something which is more, if you call it numerical, which are the finance related activities. Okay. Let me find my cursor, which seems to have run away somewhere.
Pradeep, a quick question.
Yeah.
So all these other activities did not change, but earlier you said something about their cognitive ability improving, their ability to engage in analytical processes and not listen to the gut reaction. And so why is that not affecting the unrelated processes, what you call unrelated processes?
Well, I think things like machine maintenance, right? Machine maintenance doesn't seem directly related to any sort of numerical abilities. Yeah. So most of the things I showed you in terms of the aptitude were all something to do with numbers. So if there were activities which are not really directly connected with numbers in some sense, it didn't look like those were influenced. Okay.
So the efficiency and record keeping and all that would not be related to those other activities.
Yeah, but as long as they were numerical, it does matter, right? So like keeping as long as they were now comfortable to taking down these numbers, they're better able to now say, okay, so I got so much money coming in, I have so much money going out, so maybe I should keep track of my income overall in the month. Okay, so it translates into spillovers in financial record keeping, but not necessarily in other types of activities. Yeah. So that's essentially what we find, and we also do this mediation check for the mechanism, and find that we do see these the aptitude and the activities mediate the effect. Okay, so that's essentially what we did in this study. We also then looked at was this cost, did this make sense from a cost benefit perspective, and we costed this out on a monthly basis at about $12.34. And the profit improvement, at least one of the dimensions of profit improvement, was about $25. So net, it seemed as if having a simple tool like this did in fact benefit these entrepreneurs. Okay? So just to quickly summarize that, and then maybe I can spend a couple of minutes on some of these other studies. The idea was to say, well, there are all these sort of interesting things that people are doing to show that analytics can do good. So one of the things that this study tried to do is to take that notion of analytics, but sort of a simplified version of it, and then try to see whether it improves the well-being of these small firms that whose ultimate joint well-being could improve the economy as a whole, and so does it really have any impact? And what we seem to have been able to show is that it does have an impact, and the mechanism by which it seems to have improved is this numerical capability of the entrepreneur, and also the consequent improvement in the business actions. Okay, so what we one of the things that I think people sort of worry about in a lot of these situations is, well, if these are all based on self-report, then isn't this maybe you're setting this up to be able to get these types of answers. So what we are, I think, able to do, both in terms of the mechanism, but also in terms of the sales metrics, etc. We had both their actual daily sales that they were entering, and remember those were on a daily basis. And if you compare this just to their what they think of as they report as their monthly sales at the end of the intervention, which was again a stated measure, we are able to show that these things are highly correlated, right? So in some sense, it seems as if it's not simply the fact that many of these measures we have are self-reports, that in fact they seem to be borne out by the quote-unquote harder numbers, if you would. Okay, so those we think are sort of the main contributions. I do think I have like 5 minutes, and then maybe I'll stop. Or Nanda, do you think this it's better to stop now and take questions?
If there are questions, you can take them. Otherwise, you can proceed.
Just a quick question. So these are people. These are very small vendors, if I understand it correctly, right? These are Rwanda firms.
Yes, they're very small.
Very small mom and pop vendors that sell like little things and make very little income, right? So they don't have much foundation, any kind of business foundation, and you're basically giving them you sort of taking them to the, to what we would expect a person, to have the kind of background that we would expect an entrepreneur to have or a business person to have in most economies. So does this generalize, or is there some sort of parameters that you think are, necessary to have for that kind of impact to happen?
Yes, so I think there are actually several things. The first point I'd like to make is that these are not necessarily subsistence businesses, in the sense that they have a regular place of work. They've been around for at least 6 months. There are a bunch of criteria that we had. So it had to be that they go past a particular threshold before they get included. I think that's one. But importantly, what we have found, and this is not just in this study in Rwanda, but other studies we have done in other countries, and certainly Steve has done in even more countries than I have, is that it has to be that these are entrepreneurs who have some desire to grow. So I think that that filtering survey where we do upfront, which is to identify those entrepreneurs who are growth oriented, I think that is fairly important, because if you have entrepreneurs that are just not interested, they're just like, happy going to the store every day and coming back, then I think there's a less of a chance that this would have an effect. So it has to be someone who's interested in growing. Now remember, we did the randomization after that step. So in terms of generalization, you can say, well, maybe it doesn't generalize to all small businesses, but it certainly generalizes to those businesses that have some desire and potential to grow. Okay, so I would see that as being the limitation. And having done similar studies now in a few other countries, I think at least limited generalizability seems to exist. Any other questions? Otherwise, let me just give you like a bird's eye view of what I wanted to talk about. So Shreya is going to be presenting some very interesting work with Steve, Sridhar, and Leonardo. They're essentially, I think, what one of the things they're trying to do is improve the performance of small retailers, and they're looking at retailers in Mexico. But again, where does the analytics part come in? It comes in very much, like I don't know how many of you watch home improvement shows, where they show what the shape of the kitchen is prior to the reno and what the kitchen looks like after the reno. Essentially, what they have is that what they're trying to do is to upgrade these different retailers. And so what you're essentially able to do is to take a snapshot of the retailer before, the snapshot of the retailer after, and essentially come up with a metric which tells you how much, for example, the brand of the retailer improves as a consequence of the various inputs that you now provide to the retailer. Okay, and so what they have is some very interesting ideas around sort of automating this process of extracting some kind of a brand metric by looking at the photographs of these businesses before and after. And so this is like picture analytics, but it's picture analytics which is devoted to helping small businesses, in this case in Mexico. And then I have some work with Steve, Frank, and Naufal in Uganda, where we did text analysis, which is we tried to analyze the text of the interactions between business coaches and entrepreneurs to try and see whether we could trace out the mechanism, right? And so I'm not going to go into the details, but using, again, topic modeling and related linguistic analysis, we're able to essentially show the mechanism by which this happens. So again, this is something to try and improve the businesses of, the performance of these small businesses. But to get insight into why these businesses may or may not be improving, you can leverage knowledge of analytics to actually try and measure this. And then the last thing I want to talk about and mention briefly is work by my colleague Sanjog Mishra, who's actually looking at this whole area of algorithmic nudges to improve a variety of into a variety of things which you think would require improvement. One of them being sort of the take up of the SNAP program. And I'm sure all of you are familiar with the SNAP program. It turns out that even though there are many benefits eligible families in the country, many of them actually do not apply for SNAP benefits. And so the challenge was, how do we get people to apply for these SNAP benefits? And so what they did was they were looking at these messages, that text messages that got sent out to people to remind them to apply for these benefits. And what they were able to do is to essentially featureize these text messages and then experiment with different alternatives to each of these features. So what they were able to do is that they were able to create customized or personalized messages for each profile of the individual by essentially experimenting on a group of individuals with various combinations of these different features, which make up this text message that goes out. And so I think it's, again, very fascinating that you're able to use analytics, but use it in a way that actually benefits society rather than just say, okay, I'm going to see how much it's going to improve, say, the sales of Amazon, for example, right? And so I think that's sort of my pitch today, which is, there are many things that we can all work on. Hopefully, this will be one of the things that that you keep in mind when thinking about new research topics, new research areas. Thank you very much, and thanks again to the organizers. Thanks, Nanda.
Thanks, Pradeep.
Any other questions? Anything that I can answer?
Are there any questions?
If not, have a great conference. I will try to join in wherever I can. And, hope to see you all in the not so distant future.
Thanks again, Pradeep.
Bye.
Bye-bye.
Please stop sharing. You have control, Nanda?
Yeah.
Great, so I'm up next, right?
Is it Ryan?
Yes, this is Ryan. Hi. I just need to apparently allow Microsoft Teams to access my screen share. So I'm gonna have to quit and rejoin. Just give me a sec. Sorry about that, I didn't realize.
Yeah, I had a little bit of setup challenges as well. I was shifting from teaching a class on Zoom to doing Teams, and somehow something seemed to have gone wrong in that handoff.
Okay. Everybody hear me okay?
Yeah.
And you can see my screen now? Yeah, I guess I'll take that as a yes.
No, it's frozen. We can't see anything.
Oh, you can't see my screen.
Yeah.
How about now?
Still no.
Really? It says it's sharing. Maybe I'll try a different way.
I don't know. I can't see it, but maybe others can.
I can't either. No, I can't see it here.
Sorry about this, guys. I'm showing my inexpertise at Microsoft Teams. Let me just try to figure out how to get it to show, I guess.
I mean, if you like, you can send it over to me. I can share this one.
Ryan, if you have multiple screens, it could be an issue of that.
I will. I just rejoined. Let me just try one more time. Otherwise, yeah, I can send it to somebody else. Again, I apologize for this. Still nothing?
No, don't see it.
All right, I apologize. I'm really sorry about this. So maybe I should just send it over to somebody to present on my behalf then. So who might I be able to send it to share?
Yeah, send it over to me.
Okay, sure. Do you mind just quickly telling me your email address?
NKUMAR at utdallas.edu.
Okay, I'm sending it. Might as well just try one more time while
Yeah,
we
why don't
wait.
you go ahead and try.
I do again sincerely apologize. I don't know. I should have practiced using Teams beforehand. What if I do this? Are people able to see this?
Yes.
Okay, I'll just go with this then. It's a little uglier than what I was doing before, but at least you're able to see. So once again, I'm so sorry that there was this that this wasn't able to start a little bit sooner. I'll make sure I keep my presentation a little shorter to compensate. So my name, in case you can't tell by now, is Ryan Du. I'm an assistant professor at the Wharton School, and this is joint work with Asim Ansari and Olivier Tubia, who are both at Columbia Business School. And the focus of this work is really kind of doing analytics of a very different sort than what we just heard about. This is kind of doing analytics on logos and design and branding. And specifically, sort of the motivation for starting this project was an observation that if you look at logos from similar industries or from firms that are trying to convey similar brand identities, you tend to notice that there are patterns. For instance, for these fast food logos here, you see that these logos tend to be red and yellow, but more than just their color schemes, they tend to have bulky elements. There's not a lot of white space in these. They tend to have like a 1-to-1 aspect ratio. And so a kind of motivating question was, can we come up with a model, like a statistical model or a machine learning model, that can try to kind of identify these patterns to help managers and designers make better decisions about their logos? Questions like, for instance, helping people understand what would happen if they changed their logo, say from a logo with no background to a logo with a background. Or thinking about how can we create new identities, innovative concepts. Like, for instance, what would I do if I wanted to design a new logo for a fast food restaurant, but have it be more daring or something like that? And then finally, thinking about questions related to just in general, the design process. So kind of a more general version of that last question. How can I design a logo to generate a desired perception? And so these are kind of the questions, the sort of the heart of what we're trying to accomplish in this work. Now, when we're thinking about, in general, this task of thinking about logos and branding, there's a few key perspectives that kind of are going to motivate the model that I'm going to introduce in just a little bit. Those perspectives are first the perspective of the designer, asking questions in general, like how can I design a logo that conveys my client's desired brand identity? But related to that is also the perspective of the brand manager. A brand manager isn't necessarily in charge of doing the actual designing, but is rather in charge of understanding sort of, is my logo working? Are consumers perceiving my brand the way I want them to? Thinking about if there's a redesign that's happening, which logo should I select? And then finally, of course, there's the consumer's perspective. The consumer's perspective in general is just thinking about how do logos convey meaning. If I was a consumer, which I guess I am, and I went on the street and I saw a new logo in some context, what would I make of that? What guesses or what inferences would I draw about that logo? And so the reason why I said these three perspectives are super relevant is because, as I mentioned, these are going to motivate different aspects of our model that I'm going to introduce soon. The reason that these are foundational to the model is that each of these perspectives involves thinking about data in a different way. Specifically, when we're thinking about a designer being charged with designing a new logo, that is really kind of the task of taking some features of the firm and producing a logo. That's very different than the perspective of the brand manager from a data perspective, who would be given a logo or a set of logos from which he or she has to choose, in addition to, of course, having information about the firm. But their task is to kind of understand how would that impact consumers' perceptions, brand perceptions. So all of the things under the firm's control, including the logo, are kind of inputs to this process, and brand perceptions, understanding how consumers might perceive this firm, are really the outputs. Finally, in the third case, this consumer's perspective, thinking of in general about how do logos convey meaning, that is taking just as input sort of the logo, maybe some context about where that logo is seen, and as a sort of output from that process, thinking about in general, what might this brand do? What are my guesses about this company? And so these three perspectives, although all fundamental to those questions I had on that first slide, they think about data in different ways. Different types of data are inputs and outputs from each of these three perspectives. Now, besides for the fact that these are all related in general to design, these three perspectives are also kind of based in a sort of common conceptual framework. That conceptual framework are the two interrelated processes by which consumers evaluate new logos and designers create new logos. And it's exactly this framework, which is what our model later is going to try to emulate. So when I think about how do consumers evaluate new logos, the idea is, as I said just a second ago, suppose I'm out on the street and I see a new logo that looks like this red logo here. The kind of large literature on information processing and consumer behavior tells us that basically the inferences that a consumer is going to make when confronted with this logo are going to be based on logos or brands or companies that have had similar visual imagery, similar logos to the logo that I'm seeing now. So for instance, logos that might share a similar color scheme, a similar mark, or that sort of design there, that arrow-like design. Maybe firms that have a similar font, or firms that I've seen in similar places. And it's exactly this idea of sort of when a consumer sees a new logo that is going to draw to mind a bunch of different associations. That is also what designers have in mind when they create new logos. So for instance, when designers are creating a new logo, they very often go through a process of mood boarding, which typically follows a structure like this. They've been given a brief from some client that says, I want my brand to be perceived as reliable, efficient, that we operate in the business services space, and that the really specific thing that we do is design systems for marketing integration. Given this set of things, designers often start by thinking about, okay, if we're thinking about, for instance, reliability or efficiency, are there some firms that come to mind? And what kinds of imagery, color schemes, fonts do those firms use? Similarly, if we're thinking about business services firms, what kinds of fonts, colors, designs do they use? And if there are any very near competitors in this space, what designs do they use? This will then be the basis for the designs that these designers will create, because they know that this is exactly sort of the thing that they want to come to mind when consumers are evaluating this logo. And so what we're really going to do in this project is we're going to try to understand this sort of landscape of brands in the sort of minds of consumers. We're going to try to create a mathematical representation of this sort of brand landscape, which we're then going to be able to use to understand those three different perspectives and start to answer in a decision support context those questions that I highlighted at the start. Specifically, what I'm going to go over in the next 30 minutes or so. First thing that we do in this project is we develop image processing tools that allow us to treat logos as data. This is going to be at its heart, sort of, again, it's a statistical model. It's going to be fundamentally data-driven and holistic. As part of that, we're going to need a way of thinking about logos as actual data sources. Then, once we're able to treat logos as data, we embed these brands and we embed a set of brands and their logos in a common brand identity vector space. We do this leveraging a technology called multiview representation learning. This brand identity vector space is essentially going to be the sort of mirror image or the sort of computer-based image of that brand landscape that I was just talking about. Then what we do using sort of a modification of the sort of standard multi-view representation learning frameworks, we're going to be able to build into this model specific, what we call task-specific inference networks that are going to allow us to mirror, again, from a model-based perspective, the perspectives of the designer, manager, and consumer. And with these tools sort of in our belt, we're going to then be able to use this framework for ideation and decision support. This is really kind of the key thing here, the key thing that we're going for. So what we're specifically going to be able to do is we're going to be able to use this for brainstorming through something which I call brand arithmetic, which I'll explain later. We're going to be able to use this to understand or assess the potential impact of rebrands on consumer perceptions. We're going to be able to use this to generate new logo templates consistent with a brand identity. But the reason why this fourth point I think is so important and is kind of sort of the motivating factor of this whole work is if we think about this process of design or rebranding, which all firms go through sort of at some point in their life cycles. When we think about this from the perspective of a brand manager, although designers are very, very frequently designing new logos, from the business side, a given brand manager may handle a rebranding or a design of a new brand maybe once or twice in his or her career. And so having these kinds of tools that are going to allow us to think about questions like this from a data-driven perspective is going to be, at least we hope, super useful in making informed decisions in this design space. And so this is sort of the roadmap of where we're going. Maybe I'll just pause for a second and see if there's any questions so far. Okay, great. So the starting point for all of this is, of course, data. And so the data that we have to kind of accomplish this is from 707 large high brand value American firms. Now, the idea behind this is that this is not huge data. This is, on the other hand, sort of representative data. It's representative of firms that have been sort of successful and that are likely embedded in this sort of, like I said, this collective consumer conscience of brands, this brand landscape. So we wanted to focus essentially on firms that would be recognizable, firms that have sort of successful brands, successful logos, because we're going to be using this set of brands as sort of our measure of sort of typicality of logos, of brands. We don't want that model to be calibrated on sort of the logo, say, from your neighborhood dry cleaner or someone who hasn't really given a lot of thought to how they've designed things. So from each of these firms, we take their most representative logo. We took a bunch of text from their websites. So we say specifically brand and identity relevant text from the firm's websites. In some sense, it's really just kind of like all the text from firms' websites. We also then took those logos and that text and we showed them to real consumers on Amazon Mechanical Turk. And we asked them to rate these brands on what is called brand personality. The idea being, if I was asked to sort of think of this brand as a person, what personality traits would I ascribe to this brand? And then finally, we have a set of tags that basically describe features of the firms. You can think of this as like observed heterogeneity of the firms at a very high level. An example of this is on the right-hand side of the slide with Nike. So you see the most representative logo, some of the text, and then these personality traits which is going to be sort of the basis of our consumer perceptions. Based on this, then, we need a way of working with that logo as data. And so what we do, rather than sort of what is sort of maybe more typical, at least in the sort of machine learning world, rather than working with this as in a sort of like totally unstructured way, we take that logo and we algorithmically decompose that logo into design meaningful and consumer relevant features. So specifically what we do, taking a logo, for instance, like Amazon there, we apply image processing techniques that do things like, for instance, divide the logo into different regions, then automatically identify what part of the logo is the mark or the design, the symbol, and what part of that logo is characters. And then from those things, we isolate a ton of different features. Things like, for instance, what colors are being used, what shape is the logo, the format of the logo, different aspects of the logo's font, different aspects of how complex the logo is. And the reason why I use the word consumer relevant in the sort of top part of this slide is that many of these features, which we sort of developed in this feature extraction process, are based on features that have been shown by past research, largely again coming out of consumer behavior, to be relevant for how people perceive logos. The idea being we don't want to miss out on sort of some features that have been shown by past research to be relevant. So we made sure to incorporate all of those things in this process, in addition to extracting just sort of some common typical things like color schemes. The point of doing it like this in a sort of feature extraction way is that at the end of the day, treating logos as data in this way is going to allow our results to be interpretable, to be meaningful. I'm not going to spend a ton of time going through sort of the results, but if you are curious, what we've done is we've built an app that can allow you to sort of explore our data and our sort of these sort of reduced form patterns that exist in the data. So if you navigate to this app, which you can do now or you can do after the talk or whenever you want, you'll see that you're able to make plots like the one that's shown on the screen, which lets you see basically how some feature of the firm, like for instance, the color of its logo, varies with a different feature of the firm, like for instance, what industry it operates in. And so again, I don't want to spend tons of time on this now, but if you're curious to just kind of explore our data, there you go. We've got this cool app. And so what I want to do instead of spending tons of time talking about the data is I want to transition, especially given sort of my unintentional late start here, to talking about the model that we use to do this. So the idea behind our model, it's based on this sort of broad class of models called multi-view representation learning. And the fundamental idea is that all of that data that I just described can be seen as sort of being a different view of the brand. So what we want to do is, given these different views of a brand, like what it says it does, what it looks like in terms of its logo, how consumers perceive it, what it does in terms of those industry tags, we want to distill that brand in all of that sort of messy, unstructured data into a usable sort of brand identity vector, a numeric vector that distills that brand into something that we can then manipulate in a model. The challenge of this, of course, is that there's tons and tons of different data types that we're working with here. So when we're talking about text, we're going to have a bunch of sort of binary variables saying which words are present there. When we're talking about logos, there could be anything from sort of categorical variables saying what color is present to binary variables saying did they or didn't they use bold in their logo. And so, and of course, there's going to be numeric measures too when we talk about brand personality ratings. And so this is kind of a challenge. There's also a challenge insofar as when we think about those different perspectives that I outlined at the start of the talk, each of those different perspectives is going to require us to think about this data in a different way. Remember, for instance, the manager's task. A manager, given different potential logos or given different potential changes to a brand, wants to assess what consumer perceptions might be. They're not going to be given those consumer perceptions. And so when we think about each of these different questions I outlined at the top, we're going to be facing different patterns of missing data. And so we need a model that's going to be able to both work with this very heterogeneous data types and be able to sort of make sense of this data even when we have different patterns of missingness. The model that we propose to solve that is something that is maybe generally called, I guess, a multimodal variational autoencoder with what we call task-specific inference networks. So if you've heard of variational autoencoders before, it's based on this general framework. Here's kind of an illustration of our model, sort of visually. I know it looks like a mess, but hopefully you'll understand it intuitively in a second here. The heart of this model is trying to distill for each brand that latent representation of its brand identity. You can think of that as like a sufficient statistic for the brand, right? It captures the essence of the brand. Just like in a standard variational autoencoder, the model or the sort of framework consists of two parts. On the left-hand side, we have what is called the inference network, which is essentially the way of doing inference in this setup. If you think about that latent representation in the middle, Z, as being the unknown parameters, the inference network does inference on those latent parameters. Given some data, the output of the inference network is an approximate posterior distribution over the brand identity representation. And then the right-hand side of this is what's called the decoder network, or the generative model. That's kind of like the model in some sense. What it says is, given the latent representation, given some parameters, it outputs a likelihood over features. Those could be logo features, brand personality features, text features, or industry tags. The key innovation that we introduced, so what I just talked about was kind of the essence of a variational autoencoder more generally, this idea of sort of encoding data as a sort of probabilistic model and then decoding data into a likelihood. What we introduced to this framework, though, is this idea of task-specific inferences and having this multimodal decoder network, this multimodal generative model. Let me explain to you exactly sort of how this all works, starting with that latter part, the part on the right, the generative model. So this, as I said, is kind of like the model. If you think about sort of this representation of the brand as kind of the parameters, right? What this part is doing is it's saying, given some representation of a brand, that Z, how do we define a likelihood over all of those different features that we have access to? The way that we do this, so using the notation with domains as D, features, specific features, like for instance, whether or not there's bold as J, brand as B, we're basically given a bunch of data which exists at this intersection between D, J, and B. And what we want to do is we want to define a likelihood over that X, B, J, D. To do that, what we're going to do is we're going to first specify these super simple models, right? Essentially, this most simple exponential family model that you can think of to capture sort of the support of that type of data. So for instance, since we're saying that text, we're modeling this as a binary, then what we're going to say is we're going to say, okay, the probability of seeing a word being present or not, we're going to model that using a Bernoulli distribution with a parameter that is specific to the brand and for that specific feature in the text domain. That's that mu bj text. And similarly, for brand personality, since this is a numeric trait, we're going to model this with a normal distribution. Again, super simple assumption where that distribution, again, has a brand and trait specific mean and a brand and trait specific variance. And so on and so on and so on for any of the different data types and the different domains that we have. The issue, of course, is how do we estimate a parameter for every given brand, for every given feature, for every given domain? The trick is, the way that this works is that those mu's are directly learned from that Z. Remember, this Z, that brand identity, can be viewed as sort of like the sufficient statistic of the brand, the essence of the brand. And so specifically, given that latent representation, which we modeled through this is a sort of standard assumption in the VAE literature, this normal 0, 1 prior, each of the parameters is essentially viewed as just a function of that Z, a function which we estimate with a fairly simple, honestly, neural network. And the idea behind this is, given Z, given this latent representation, which our goal is to be able to estimate, but given it, we can infer all of those feature-specific likelihoods. It's just essentially a deterministic function. After you've got that Z, it's just this function, this map from Z to the mu's. And so really the heart of this model is all about that Z. Once you have Z, you know everything there is to know about the brand. So how do we then infer this Z? Well, the way that we do this is, again, sort of mirroring the standard variational autoencoder literature. We specify something called an inference network. The idea behind this is that unlike sort of standard Bayesian inference or even just standard sort of maximum likelihood, rather than sort of running some long Markov chain to try to infer the posterior distribution of Z or running maximum likelihood to infer the sort of best value of Z, the most likely value of Z, what we do instead is we pose this function as a function estimation problem. So the idea is we want to come up with a function that says, given this data, this is the approximate posterior of Z. But instead of sort of learning that function implicitly through a procedure like maximum likelihood, what we do is we model that function explicitly. Before I show you how that works, first, the basis of that function is that we're going to make an assumption. We're going to make an assumption that we can approximate the posterior distribution of this z through what's called a mean field variational family. That is, we're going to posit that the sort of the posterior for all of the components of z can be approximated by a simple normal distribution, where there's specific parameters for the brand and for the component of that distribution. For that component of z, b and k. Then the goal is then, okay, so we've just kicked the can down the road in some sense. Now we need to figure out, okay, given data about a brand, what are these parameters of that approximation? That's where we have these task-specific inference networks. So again, the idea is we're going to replace the task of, again, like maybe running some Markov chain or doing maximum likelihood with the task of estimating a function. It's a function that goes from data to those parameters. That's the idea of an inference network, or amortized inference, as it's referred to more widely in the literature. But what we do, beyond the sort of standard setup that, again, you may have seen if you're familiar with this sort of VAE space, what we do is we introduce not one inference network, but a set of inference networks, where each of these inference networks mirrors the task of interest. So we're going to have one inference network that essentially acts like the designer. That inference network is going to say, given information about the firm, except for its logo, what is our sort of best guess at the posterior distribution of z? What is our best guess at that z? Similarly, we'll have one for the consumer, we'll have one for the manager, and we'll have one for the full data. With this setup in mind, the sort of way that this actually works in terms of estimating it, we're going to minimize the sort of KL divergence between this approximating posterior family and the truth. We do this by sort of standard variational inference procedures. We're going to maximize an elbow, evidence lower bound. And the way that actually happens is by learning the parameters of this function, this approximating inference network function, those are phi, and also by optimizing those parameters of the decoder network that I talked about on the last slide. And so if that all went by too quickly, I understand, and I partially put myself in this situation again because I couldn't get my slides up here quick enough. Hopefully it'll make more sense when I go through this sort of simplified example here on the next slide. So in sum, basically, the way that this procedure works is that we have, our goal is really to infer what the latent representation of a brand is. Once we have that, we're going to be able to understand all of the sort of feature likelihoods. So we really need, given some brand, we need to be able to figure out what is that brand Z. The way that this works with those task-specific inference networks is, say, for instance, suppose I want to answer a question about design. I will have at my disposal information about what the firm does, text, like in, say, for instance, a brief that might be described to a designer. And then I'll also have in my head sort of what brand personality I would like this firm to convey, or what brand personality this firm would like to convey. Given that data, but not data about the logo, this task-specific inference network idea, specifically the designer's inference network, allows us to take those three things as inputs and infer and estimate our best guess basically at this Z, this latent representation. Remember, this Z is essentially a sufficient statistic for the brand as a whole. And so once we have this Z in hand, we're going to be able to then infer things like, for instance, the parameters of the logo likelihood, which wasn't given to us. We'll also be able to infer the parameters of all the other likelihoods too, but this is kind of the real use case from a decision support perspective. We're going to be able to, given that Z, figure out what features might be in that firm's logo. That's the idea behind this task-specific inference network idea. It's one of the sort of big things that we do in this. The other big thing that we're going to be able to do with this model is, of course, for each brand in our data, we're going to have our estimates of that Z. And I'll show you in just a second that with those estimates in hand, we can do really cool things. Like, for instance, think about ideation, think about sort of forming new brand identities. Let me just pause for a second and see if there are any questions about what I just went through. Okay, I guess we're good then. So moving then on, so in terms of the results. So first, I should have led with this. So we've been very actively working on revising this paper. We're really actually like pretty nearly done on a big revision of this paper. And so in the results that I'm going to show you in just a second, there might be some new things that weren't there in the original. Among those new things and among the things that we've been recently working on that I'm not going to show today are things like, for instance, model fit and comparisons to some benchmarks. So we have compared this sort of framework to a lot of these sort of standard frameworks or even kind of cutting edge frameworks that have been introduced in the multi-view representation learning space. And yes, we can do better than these in terms of a host of different metrics, anywhere from sort of reconstruction error to out of sample sort of predictive fit. Another thing that this model can do, which is kind of fun, but I won't have time to share with you, is it can actually be used to generate completely random brands. So this sounds kind of useless, but it is a cool way of being able to sort of verify that the model has learned something interesting, because we're going to be able to essentially say, okay, do these random brands that it's generating make sense? If it does, then it's evidence that that generative model, part of our framework, is actually learned appropriately. And actually using that sort of random brand generation thing, another thing that we've done very recently, which I again won't be sharing today, is we've actually used this to then validate that the model generates and it produces insights that consumers also think make sense. So we took this, we've shown different aspects of this model and its results to sort of real live people and ask them sort of questions to get at, do they think in the same way that the model seems to be thinking? And indeed they do. So we validated the model in that way too. What I will show you, and again, cognizant of the fact that I have only a few minutes left, I'll first briefly show you just what this latent space is actually learning. Then I'll talk about sort of how we can use those learned representations for ideation. And then I'll go through two quick examples about how this can be used for decision support, which, as I said, is what I view as sort of the big contribution of this framework. So first, do the learned representations actually make sense? What are we learning? What are those Z's? So the easiest way to think about that is through some examples. And here I'm showing two examples. The way that what I'm showing you here specifically is I've taken a focal brand, Facebook and McDonald's, and I'm showing you what firms are closest to that brand in this learned latent space, this representation of kind of the collective consumer conscience, as I called it before. So you can see that the firms that are going to be closest to the focal brand in this space, this is not like a market mapping exercise, right? We're not talking about competitive structures or anything like that. The firms that are going to be closest to the focal brand from our model's perspective are going to be firms that have as much in common with the focal brand across all of the domains as possible. So for instance, Facebook and Twitter, they are neighbors. Why are they neighbors? Well, they operate in similar spaces. They use similar words on their websites. Their logos share features in common. Like, for instance, both are blue and bulky, have just one color, not a lot of white space. And consumers perceive them in similar ways. Similarly for Uber there. McDonald's nearest neighbors, on the other hand, are a little bit less intuitive, but it becomes a little bit more intuitive as you think again through this idea. The model is really trying to find things that are similar across all dimensions. So McDonald's has, especially actually relative to those other fast food firms, a relatively simple logo. And again, we see that the model has identified firms that also have similar looking simple logos to McDonald's. We find its nearest neighbor is Heinz, similar in some sense to sort of the mission, what the firm is doing, but not a fast food company. These firms are also perceived similarly in terms of consumers' minds, and they use similar language on their websites. So in short, this idea of sort of what is the model learning? Well, this Z space, these Z representations that the model has learned are again trying to capture similarities across all of the domains. So what can we actually then do with this sort of learned representation space? Well, one really cool thing that we can do is this thing that which we call brand arithmetic. The idea here is what we can do is we can take different points in this space and we can interpolate between them to come up with meaningful concepts. So for instance, we can do this with brands. So if we ask the model, okay, we have a representation for Mercedes-Benz and we have a representation for Old Navy. What's the midpoint between those two things? Or Nike and Louis Vuitton, or Google and McKinsey? And the idea is, this question is sort of like saying, how could I fuse together Mercedes-Benz and Old Navy to come up with a sort of new brand concept? And so the results of doing this are actually super, super fun and kind of intuitive. So for instance, the midpoint between Mercedes-Benz and Old Navy is Burberry, a luxury clothing company. The midpoint between Nike and Louis Vuitton is Calvin Klein, a kind of sporty sort of, but again, sort of more upmarket clothing retailer. Midpoint between Google and McKinsey is this firm Cognizant, which provides IT consulting services. Similar other firms at the midpoint there are like IBM, again, that kind of exists at this intersection of business and technology. And so we can see that this produces really kind of cool, interesting results. But I would say that this is more cute than it is useful. To think about how this can actually be useful, we can apply this same brand arithmetic idea to come up with new brand concepts. For instance, thinking about what might a daring fast food firm look like. So we maybe you know, maybe you don't know, most people don't view fast food companies like McDonald's as particularly daring. And so what would happen, how could we think about, from this perspective of our model, coming up with a more daring fast food company? So the idea is we're going to try to add the daring personality trait to a typical fast food firm. From the language of brand arithmetic, what this means is we're going to take the average Z vector corresponding to a bunch of fast food firms, and we're going to add to that the average Z vector corresponding to a bunch of daring firms. And we're going to think about sort of what pops out when we do that. And how does the, say, for instance, suggested logo features change as I add increasing amounts of sort of the essence of daringness to the essence of fast food. So just to remind you, a bunch of fast food firms here, we took basically these guys here and we averaged their vectors together. Not all of these guys here, like In-N-Out is not in our data, for instance, but firms like these averaged them together to come up with an average fast food representation. Then we added to that sort of a representation corresponding to the most daring firms in the data. And the model suggests to us how the logo should change if we wanted to make these fast food firms more daring. We should, for instance, lower the number of colors, increase maybe the likelihood of having black in the logo, lower the probability or lower the amount of boldness that we're using, and lower the number of corners, the angularity of that logo. So it's pretty cool from a sort of brainstorming perspective. Yes?
Sorry to interrupt, but you have 10 minutes left, just to mention.
Wow, I still have 10 minutes left. I thought I was done in 3. So, okay then. There's not 15 minutes left for the discussion?
You started late. It was like 2:08, so.
Okay, well, I'll try to finish up so we don't interfere in the sort of the next time slot. But thanks again. Yeah. So the last kind of 2 examples I want to show is the sort of idea of, as I said at the start, the most important thing from our perspective about this whole work is using this for decision support. Like I said, very often sort of managers, when faced with the task of sort of either designing a new brand from scratch or reimagining an existing brand, they will not have had a ton of experience with this process. Although there are design firms and consultancies that can help, having tools that can allow us to think about this process from a data-driven perspective can be super useful. And so as a case study, let's imagine this is actually a true case study. Let's imagine we're thinking about redesigning the McDonald's brand identity. So at left in this image here, we have what was kind of like the standard McDonald's logo from the 90s. They actually went through several different logos in the 90s and 80s, but this is kind of the typical sort of roadside McDonald's logo that you may see when, if you're driving down the highway. Sometime in the sort of late 2010s, I think it was, they switched to this very simple sort of golden arches design. And then in the last 2 years, they've been, instead of using the sort of background free version of this logo, they've been using a version that has a red background basically all the time on most of their promotional materials. And so we can actually use our model to think about how would consumers perceive, say, this relative to this. A simple change of just adding a red background, and yet our model is going to be able to sort of assess how things might change, how perceptions might change. So what I'm showing here on the right is I'm showing the model's predicted sort of differences in the brand personality perceptions of consumers when either given this logo relative to the old logo or given the red background logo relative to the old logo. So all of these are relative to that old logo. I'm really just using that old logo as like a baseline here to understand these differences. The way that this mechanically works is, remember that we had this inference network that took the perspective of a manager. Given inputs about the sort of what the logo is, what the firm does, and how it describes itself, this part of the model is able to learn the relevant Z for that brand and then predict consumer perceptions, something that it was not given. In this case, the model makes predictions that are, in some sense, stark. Now, these are not huge differences in terms of these ratings. They're slight differences, as you might expect with a slight change to the logo. But nonetheless, the model seems to suggest that in terms of many features that McDonald's may be interested in conveying, like contemporary, exciting, trendy, that version with actually no background, just the simple golden arches all on its own, is going to be better than that version with the red background, the one that they've actually recently pivoted to. Similarly, this version with the red background is actually not particularly good in a lot of different ways. So for instance, relative to kind of old classic version, that version with the red background, our model predicts is going to be perceived as less charming and less honest. And we can go through the whole set of brand personality traits for this sort of thing. But what I hope you'll take away from this is that this model allows us to think about changes aesthetically in a predictive sort of data-driven fashion, by basically sort of averaging together all of the different logos and all the different perceptions that sort of have existed out there and thinking about the impact that these, or the correlations that exist between those brands and sort of consumers' perceptions. The last version of this that I'll show you, the last sort of decision support task, is the task of actually coming up with a new brand. How can we assist designers and managers when they're designing new brands from scratch? And so the idea here is what we're going to do is we're going to think about designing a sort of look-alike brand. Specifically, if you've seen kind of more recent entrants to this fast food space, companies like Shake Shack, for instance, you'll notice that they're not always following the same exact pattern here. And so what we're going to do is we're going to suppose we're in the shoes of designing a new fast food firm. We're going to base this new fast food firm exactly on Shake Shack, which wasn't one of the firms that was in our original training data. Then we're going to see what insights the model can provide when thinking about designing this brand. And then since our sort of fictional new brand is actually based on a real company, we're going to be able to then think about how accurate the model was. Now, as I said, we have predictive results that show the model is fairly accurate, but this is going to be kind of more anecdotal evidence to show that the model is able to come up with reasonable suggestions. So specifically, the way that we can think about designing new brands in this model is through that designer's inference network. The idea being, what we're going to do is we're going to take a bunch of words that we actually took from Shake Shack's real website. Then we're going to input a target brand personality. Now, this was a choice for us. We said basically, okay, let's suppose our new fast food firm wants to be perceived like as exciting, as cool, as glamorous, as up to date, but not particularly outdoorsy, rugged, tough, secure. We thought about this essentially from the perspective of, again, what is Shake Shack likely trying to target here? Given these things, the words on Shake Shack's website, this target brand personality, in addition to some tags basically saying that Shake Shack's a restaurant, what we're going to be able to do, again, is we're going to be able to plug those things into that task-specific designer inference network. We're going to be able to come up with that learned representation for this Shake Shack lookalike brand, and then we're going to be able to make predictions about its logo. This, from a decision support perspective, is equivalent to essentially saying, okay, you've given me a firm that you want to create. I am going to be able to suggest to you visual features that would be consistent with a firm like that. And so here's what the model produces. The model produces a bunch of features that are, in some sense, consistent with the reality of Shake Shack. So remember, Shake Shack wasn't one of the firms in our data. We're just using this as kind of a hypothetical. But nonetheless, we see, for instance, that the model suggests that the firm's logo would have a dominant black color. We see that the shape of it would be a medium oval as opposed to that sort of square design that we saw in many of the other firms. We see the font would be sans serif, which indeed it is, although that's typical for a lot of restaurants. We see that it would either have many colors or 3 colors. This is a departure sort of from reality here. The model suggests that the firm would have, for instance, a geometric lightweight font, that it would have a high percentage of white space. All of these things could be used by a designer to think about then crafting this new image. Now, it's not going to go all the way, and we don't view this as a sort of replacement of a designer. Designers could then come in based on this, which is essentially the replacement of sort of a mood boarding process, because it's based on that whole set of typical firms that are out there, and then build on it, introducing, for instance, like this neon green logo, which you'll see is nowhere here in the predicted visual features, to craft that kind of final brand identity. Okay. So I tried to go quick. Again, I apologize about the sort of late start. Hopefully this leaves enough time for discussion and doesn't put us too far over the sort of edge here. In summary, basically, what we've done in this project is we've developed these tools for understanding logos from a data-driven perspective. The idea here is that we have this image processing algorithm that gives intuitive, relevant features that can be interpreted and is based on prior research and theory. By fusing together textual and visual data, we can better understand these common themes of design and branding, and in particular, use this for sort of creative tasks and for providing decision support for this kind of classical sort of creative task, making it a little bit more data-driven. Thanks a lot for your time and for coming, and for the conference hosts for inviting me. If you're curious, we are posting the working paper at my website here, and there should be a new version available very soon. And you can also, of course, feel free to contact me with any questions. Thanks again.
All right.
Thank you. Do I need to stop sharing for you to be able to share? Probably.
I think I should be able to share here. Give me a moment. Okay. Can everybody see my screen?
Yeah, you're much better at using Teams than I am.
Not really. I learned some lessons here. All right. Thank you for having me here. I'm Dinesh Puranam. It's a privilege to serve as a discussant for this paper. It's a really interesting paper, and I think it's an interesting problem. The idea of quantitatively trying to support logo development is novel. It's correlational in nature. It's rooted in the current existing practice in the industry, obviously, but it's great for ideation. And I think the focus is on typicality of logo features, and I think that's an interesting idea to develop using some of these tools. So the process seems to be basically to extract interpretable features discussed in prior literature on logos. I thought this was amazingly comprehensively done in terms of the detail and attention paid to the very large literature, especially on the CB side, which tries to interpret different aspects of logos and to use computer vision techniques to translate that to something quantitative, I think helped really build the story here. And in the process, this paper proposes to introduce a multimodal model, which is another term for saying using multi-domain or multi-data type model to provide decision support to managers and designers and researchers, as well as to understand relationship amongst brands. And so that's some of the brand arithmetic that Ryan just finished off of at this point. So I'm going to focus my comments on the modeling choices, some alternative approaches, and I know Ryan mentioned he's already looked at some of those, and maybe that's part of what I'll be talking about here. And also a separate concern in general about underspecification in deep learning models, which is not specific to this paper, but would be of interest, I think, to this audience. All right, so let me get started here in terms of the variational autoencoder. That's where this modeling effort really starts. And so this is the standard setup. You have the input on the left, which tells you the different aspects of logos, how that's encoded into some version, which leads to a latent representation that's decoded, and then that generates back what you set out as input. And as variational inference goes, you have an encoder network here, you have the Z, the decoder network, and you optimize the elbow, just as Ryan mentioned earlier. And the difference between this specification and the multimodal autoencoder is really this idea that you have different types of data, and so you need to distinguish between them. And so they have their own representation networks or encoding networks. And then the question is, how do you represent this jointly to result in a latent representation that exploits the within domain knowledge, but also has this shared understanding across domains, which can then be used to recreate your inputs. So this has been the traditional view, or at least the recent literature in how this has been presented as a multimodal model. And so the key item here is, how do we combine these individual domain-specific knowledge elements into something that can be joined together to generate this latent representation? Obviously, you have, with two types of data, you have 2 to the power of 2 options or combinations, including the null set. As you have more, it becomes 2 to the power of m. And so it's not really possible to look at all these subsets. And so you need some way to factorize this. And so in the literature, the idea is that you could use a bunch of different ways of factorizing this joint distribution of the latent variable for the encoding network. And so that comes from Product of Experts, which is the Wu and Goodman paper, which talks about basically thinking of it as a product of within domain encoders. And that's different from looking at a mixture of experts, which is really about considering the joint as really a function of the individual domain-specific encoding network. So it's some weighted combination. In this case, it's a straight average that we're looking at. And of course, once you have product of experts and mixture of experts, you can have a product of mixture of experts. And so there are more elements in how we get to combine these domain-specific learning elements to join together to create a common representation for the latent vector Z. And so this is quite different from what we see in the current paper, and I think that's a novel contribution here, but I thought it worth to share the context as to what makes that novel. Each has various pros and cons, and looking at just the top 3 different options on how you represent that particular conditional distribution on the 2 different domain types of the latent vector, it's quite possible that each has strengths in terms of the representation, the conditional representation versus the marginal estimates that it learns in the process. And so what that means is we need to understand in this context how task-specific encoder networks help code that information, and do they necessarily perform better or worse or about the same. And so that leads us to thinking about, in the specification, it looks like they're really looking at having task-specific encoders which don't take into account the individual within domain expertise that can be learned from the autoencoder structure. The literature does that, and the factorization step tries to combine these different elements into this joint representation, but it's not really clear how looking at it as a group of domains at a time necessarily generates that particular representation. The results are very, very interesting and seem very persuasive, but it would be helpful to understand what precise mechanism generates that kind of learning that is a good representation of these multiple domains. So for example, in each iteration, the updates to the parameters on the encoder side is based on where the example falls in the task bin. So if it falls in a particular task bin, then that set of parameters are updated. And so the question is, when you learn that from that example, you're actually learning about a few other things within that task bin. You're learning about text, you're learning about the brand personality. How does that then affect the next element directly? And so certainly in the posterior, it does converge because you have information on the decoder side and the latent representation itself, but the composition is not as direct as some of the existing literature. And so I think it's worth considering what is it that we gain in exchange for that representation format. And it would be good to see a comparative benchmark in terms of performance and quality of representations. The other element that I found interesting is when we typically talk about variational encoders, we talk about estimations where we are trying to maximize the marginal likelihood of observing the data. But it turns out that the traditional multimodal variational encoder, it's funny that I should call it traditional given it's a paper from 2018, but I guess I've spent so much time looking at this paper, seems to give more importance to the marginals rather than the conditionals. And so I know we didn't get to talk about this in the paper, in the presentation here, we didn't get to hear about it. But if you think about it, the original work from Wu and Goodman looks at the full data, each individual domain, and all convex combinations within that. And so each elbow element, which is optimized, corresponds to that marginal of the data. And for a two-domain example, that basically boils down to the full and each individual domain. And as you can see, there is some bit of redundancy in the elbow structure. It's not only not a lower bound on this, but it double counts the marginals here. And so this is an issue that does happen with multimodal variational autoencoders, wherein you end up double counting these marginals, which might be one explanation for why the mean absolute deviation error in predicting the manager's problem, which is to understand the brand personality given all else, is maybe not as good as one might have hoped for. It's because maybe this objective lower bound has some issues with that. And so there are a few options that might apply in this case as well. And so there's some options that are worth investigating as benchmarks to see if that might alleviate some of these issues and give us better prediction performance, both and reconstruction errors. In addition to that, the other area that I thought that was interesting was to think about some alternative approaches. Given that this is a really interesting application of looking at multiple domain types of information, it's useful to think about more aggressive benchmarks than, say, simply the no information rate of simple averages, which is in the paper. And I know Ryan mentioned that there are other benchmarks they've tried, and it has worked well in the multimodal literature or the multiview representation learning literature. But I think there's some other things that we might be able to do as well. The general motivation for multimodal generative models has been to really focus on scenarios where it's expensive to collect paired data and it's inexpensive to have specific domains, specific data where you have text and images, but they are not matched. Getting labeled images or texts with images is more expensive. And so this falls into that area of weakly supervised learning where multimodal methods seem to help because they can learn both from the small number of examples, but also from a large volume of individual domain-specific data. And that's essentially what this comment here says, and something similar is echoed in Shi et al. In 2019. So in general, as the labeled data increases, the multimodal supervised models outperform the multimodal generative models, and that's sort of documented. So then the question is there a reasonable benchmark to apply here in terms of looking at supervised learning as an alternative? And so the question is, can we input text?
Sorry to interrupt, but 5 minutes.
All right, thank you. So if you were to include text, brand, personality, industry, can we get to build a simple supervised model that predicts the logo features? I think yes, it's possible. We could do the same for the manager's problem. We could try the same with the researcher's problem as described. Conceptually, it is possible. Is it going to perform better? Maybe. Interpretability in this framework really comes from the extraordinary work done upfront to extract the features. So it's not tied to the multimodal variational autoencoder. It could be whatever format that you might pick. So that could include a supervised model. And so there's possible then that given you have 706, which I think was in the paper, but 707 observations, it may then be possible to, in a supervised framework, make use of some of the transfer learning methods as well, which might improve prediction accuracy as well. And of course, you can attribute using something like Shapley values, and we can talk about that. And the other aspect that then leads to, which is very interesting, and I really enjoyed reading this section of the paper, was given these latent representations, can we generate these random brands? Can we try and understand how these different brands, when they combine different attributes, can we generate a new profile, right? And from an ideation process, that point of view, that's very, very helpful. And so I think in the current approach, the idea is, for example, identify brands in the top decile of daring and compute and average the latent vectors of these brands. Do the same by identifying the industry, and then construct a weighted combination of the two vectors and look for brands which are nearest to the new vector, or alternatively try and predict the industry tags, personality, and other dimensions, etc. Conceptually, you could do that by looking at just the individual autoencoders and looking at the brand perception data. The supervised models from the previous slides could be applied to generate each of these elements, like the industry tags and the personality tags, etc. Of course, we can then also separate out these spaces. So we would then be able to see what specific dimensions are these logos or brands similar, either on text, or they're more similar on a specific aspect, which is around the logo or the personal or the brand personality aspect. And so that's something that you gain in exchange for the hard work of now having to have separate models. But it is much less appealing. I fully understand that. I think the authors do as well, because there is a trade-off that they document between the reconstruction error, the prediction error, and bias. But in a pure predictive framework, you're then just focused on prediction error, and you may have better control on what you're actually estimating and representing there. It is also possible that in the context of small data, supervised models may actually do well with multimodal methods. It's a benchmark worth investigating. At worst, you will have a different set of models that work to answer the same business questions, or you might find methodologically a new contribution to offer up, which says these models might actually do well with small data as well. The last point that I want to focus on real quick here is this idea of underspecification. There's a cheerfully titled paper called Underspecification Presents Challenges for Credibility in Modern Machine Learning. It's by a group of researchers at Google. I found this very interesting because what I think may happen is a lot of models which perform similarly on the test set may have very different internal representations. So for example, we have two different random initializations of a transform model called BERT, and that will yield very different relationships between, say, the gendered nature of different occupations. I'm not sure I have enough time to get into this in detail, but suffice to say, two different random initializations learn different representations, which lead you to different conclusions, which is a cause for worry. And so from that perspective, I think it might be a good idea to add some additional ensemble approaches, or do multiple random samples and random starts to see if these latent vectors are pretty much stable or not. The nice thing about variational inference is that you don't not only get the latent representation, you also get their distribution. So you can now look at statistical properties of how those latent vectors compare with each other. There are a few minutiae in terms of text, and the brand personality may be redundant because one is being used to generate the other, and other elements within that, but I won't take up too much time on that. From a summary perspective, I think this is a very interesting project. It fills an important gap in the literature. It's very thoughtful and careful approach to feature extraction process, and it introduces multimodal literature's methods to the marketing literature. And so it has a potential for high impact both in academia and industry. So that's all I have to say. Thank you.
Thanks so much. This is great.
Sure. Let me stop sharing here. Am I still sharing, or have I stopped? I think
You're still sharing for me.
Sorry. Okay, let me stop that. All right, I hope I was within time.
Okay, so now I can share, I guess. So can you see my screen? Thank you.
Yes.
Right. Thank you. It seems you hear me well. All right, yeah, so let's get started. So thank you for joining us, and also thank you for organizers to put our paper into the program. What I'm going to talk about today is attention and inattention to baseball telecast. This is a joint work with Xiao and Matt. Yeah, Xiao is here. I'm seeing you. I'm not sure Matt is around, but yeah, this is a joint work with Xiao and Matt. Okay, so the motivation of this paper is that, well, TV viewing is still very important. Well, media entertainment is an important part of our life, and actually we spend a lot of time for watching TV. The table I have here in the slide, this is coming from the American Time Use Survey in 2018. This table shows that adults in the US spend 20% of their waking time for consuming entertainment and watching TV. So if you look at the watching TV column right here, the American adult on average, the male adult spends 3 hours in front of TV, and the women spend 2.61 hours in front of TV. That's a lot of time. So we spend a lot of time in front of TV still in 2018. Okay. And in particular, while during this COVID pandemic, we spent even more time for watching TV. A recent survey done by Nielsen showed that streaming of TV content nearly doubled compared to the last year, 2018. So we spent even more time in front of TV during COVID pandemic. The table right here I have in the slide, this is the Japanese data. This is not the US data. In this table, this shows that compared to the previous, the before COVID and after during the COVID and after the COVID, how much we spent more time in front of TV by the different age groups. So teenagers and the age between 20 and 34, 35, 50, etc. And overall, we see across all age groups, we see increase in time spent in front of TV. So they watch more TV in front of TV. Well, teenagers are kind of interesting because they watch less during 6 and 9 a.m. and they watch even more, like more than 33% increase during 2 to 6 a.m. So teenagers don't go to the bed during COVID. Okay? But other than that, we spend more time in front of TV. Okay, so it is still important to understand our TV watching behavior. Okay. That said, I think the measurement of TV watching is getting more and more difficult because when I'm watching the TV on a couch, I typically have a smartphone and a tablet, and I easily get distracted by Twitter and other social networks. Right, so this is a bit old data, but a Pew Research, they did a survey in 2012, and they found that half of the US smartphone usage are actually happening when people are watching TV. So even though TV is on and people are sitting in front of TV, but most of the time they are not paying attention to the screen. Right? So the metric, TV rating metric, which is based on whether TV is on or off, it's probably misleading because people spend more time watching, using smartphones and tablets when they are watching TV. Okay, so that's the kind of the gap we want to look at. We want to understand the difference between, sitting in front of TV and also actually paying attention to the TV contents. And then, what are the key determinants? What are driving force when we are watching TV? Right. I think there are many other factors. There are many factors that affect our watching behavior, but this example kind of shows one, key factors, the two key factors that we're going to focus on this paper. So, this is like example. This, like you see, this is the election results, the presidential election results in last November. When I was watching, the progress of the election results progress, I was like this. Because, in some states, the election results were never finalized. It's very suspenseful. But in other states, the results were flipped from last election results, kind of surprising results. So there is a series of suspenseful moment and a surprising moment that kind of attracted our attention to the TV contents. Right? This is just one example. We are not going to look at the presidential election results in this paper, but this observation kind of motivates us to look at the impact of suspense and surprise as key driving factors of our attention to TV programs. Okay? I mean, there are many other factors that might affect our viewing behavior, but in this paper, following the previous papers in this literature, we're going to mainly focus on, well, the impact of suspense and surprise on our viewing and attention behavior. Okay. So the research questions we're going to ask in this paper are the two things. First of all, we're going to estimate a model to understand how do TV contents affect viewing and attention behavior differently. Is there any difference between viewing behavior and attention behavior? And what are the key factors in that? That's the first thing. In addition to that, we are interested in how should the TV planner design TV program contents to increase the customer attention, the number of eyeballs of TV viewers. Okay, so our research question is relevant to the product design question. We want to design the TV program contents to maximize the consumer welfare, or in other words, the number of eyeballs that consumers are paying attention to the screen. And I think this has huge implications for advertisers as well, because we want to understand when is a good timing and the best timing to have advertising. Should we have advertisement when during the suspenseful moment or during surprising moment, depending on what's happening during the TV programs, that may influence the attention to the commercial as well. So we need to take into account the sort of spillover effect or externalities from between TV programs and advertisement to think about the impact of advertisements on TV viewers. And the particular application in this paper is baseball games. We're going to look at the Japanese professional baseball game telecasts. So the program design aspects that we're going to look at in this paper are the rule changes of baseball games. Currently, Major League Baseball games are talking about possible rule changes. There are several rule changes they are talking about. For example, why don't we shorten the game from 9 innings to 7 innings? Or why don't we allow mercy rule, under which if one team outscores the other team by like 7 points by the end of 5th innings, then the game is going to end at the point. So allowing like shortening the game or mercy rule, how those rule changes impact the viewer's behavior and what are the implications of those rule changes to the advertisers, attention to the commercials. That's the research questions we're going to look at. And in terms of related literatures, I'm not going to talk about all papers. There are so many papers in this field, but there is a growing literature about suspense and surprise. So there are many papers now looking at the empirical effects of suspense and surprise on viewing behavior. Okay. Some of the papers in this literature are looking at the aggregate TV rating data, so they don't have the individual disaggregate data set, but they're looking at the aggregate level TV rating data and to see the impacts of suspense and surprise on the aggregate level TV rating data. Those papers are also looking at sports like tennis, football, etc. We are going to look at baseballs. And the Andre and Raluca's paper, I think they're going to present this paper in the last day of the conference, so you should pay attention to this their talk as well. They're looking at different contexts. They're looking at the game watching behavior, but they are looking at the disaggregate data sets. It's kind of similar to our data set in terms of granularity of the data set. Okay. And our key contributions of this paper is, again, we want to highlight the differential impacts of suspense and surprise and other program contents to viewing behavior and attention behavior. We want to separately identify the effects of the program contents on viewing and attention. Okay? And also we want to highlight the impact of spillovers from TV programs to commercials to see the implications for advertisers. Okay, so this is about the setup, and I'm going to talk about the data, but let me pause a little bit here if there are any questions. Okay, great. If you have any questions, please interrupt. Okay, so let me talk about the data. We combine two different data sets for this analysis. The first data set is coming from Television Insights. They have offices in Boston and in Tokyo. And in this paper, we're going to look at the data from Tokyo. But actually, we are working on another project looking at the presidential debates. And for that project, another project, we are going to use the data from Boston office. But for this data set, for this analysis, we're going to focus on the Japanese data. What the company basically does is they recruit a bunch of people so that they put this device in this image. They put this device on top of the TV, and this device has the deep learning based facial recognition system, and that allows us to identify each individual viewer in front of TV. Okay? And also they measure whether the person's eyes are open and the eyes are actually paying attention to the screen or not. Because of this facial recognition system, we can separately identify each household member within the household. Okay. And for the Japanese data, we're going to look at in this paper. They recruited about 900 households. It's increasing over time, and 1,500 individuals in Japan. Okay. You might be worried about some sample selection problem here, but what I can say is they're trying to make the sample as represented as possible, following how Nielsen collected and recruited their household panel. Okay, so there might be some sample selection, but they are trying their best to make the data representative as much as possible. Okay. So the data we have in the original data is the second by second and individual level viewing and attention data. Oh, by the way, they also collect some information about facial expression, like whether the person looks happy or crying or sad or something like that. That's kind of interesting information that if we can use, but for the privacy reasons, we are not using that data for this analysis. Right. So, like I said, we have individual level, second by second information about 3 different variables. W. This is whether TV is on or off. V, this is whether an individual is in front of TV or not. And we say this is viewing. And E, this is whether eyes are actually looking at and paying attention to the screen. We're going to say this is attention. Okay. Due to NDA, I'm not allowed to show the detailed summary statistics of the original W, V, and E metrics. But we found that only about 1/3 of the time people are sitting in front of TV is on, but only 1/3 of the time their eyes are actually paying attention to the screen. So there's a huge difference between the viewing or sitting in front of TV and the TV is on and actual attention to the screen. Okay. They also collected information about TV programs and commercials. So we know the brands of each commercials, and also we know the YouTube video of each commercial, etc. And for this analysis, we're going to look at the baseball games. Okay. In 2018, that we're going to use the data for the analysis, we have 41 different games broadcasted by the national TV channels. And for each game, on average, we have 500 unique members. That's the first data. That's about attention and viewing data. That's the kind of main part of our data set. And we combine this attention data to the Japanese baseball game data. The reason why we're going to focus on baseball is, of course, the baseball is one of the most popular professional sports in Japan. This is actually the most popular professional sports in Japan, actually more popular than sumo wrestling. Therefore, many TV stations regularly broadcast baseball games, and we have a lot of observations. But more importantly, the reason why we're going to focus on baseball games is that the baseball game allows us to characterize the game contents and the states in a kind of low-dimensional state space. Okay. In order to characterize what's happening during the game, we can characterize innings and outs, bases loaded, differences. Sorry, I heard some noise. I'm going to mute. I think this is DI. I'm going to mute you. Sorry. So for the baseball games, it is relatively easy to characterize what's happening during the baseball games in a low-dimensional space. But if you want to look at, let's say, the basketball, or football, or other types of sports, it's harder to characterize what's happening in the game. Okay? So the baseball is relatively easy to analyze statistically. Okay? And also each game is different. So we have rich heterogeneity across different games that allows us to identify the effect of suspense and surprise and the program contents on the viewing behavior. Okay. That's a data set. And the baseball data is coming from Data Stadium. And this company records detailed information about all professional sports in Japan, in particular baseball games. And we're going to use the data from 2018. The good thing about this data is we have timestamp of each event during the baseball games. So therefore, we can easily match the baseball game to the attention data. Okay, so there's a clear mapping between the two data sets. In terms of some summary statistics, we're going to use the professional baseball games in 2018 that has like about 900 professional baseball games. And the probability that home team is going to win is about 42.4%. But if you focus on the data that are broadcasted in 2018, that's 41 games. And among this data set, the home team winning probability is slightly above 50%. Okay, so all games in 2018, we don't really see kind of home team advantage, significant home team advantage. But among the games that are broadcasted, we see slight kind of home team advantage. So let me give you a few descriptive analysis to show the relationship between the program contents and the viewing and attention. Okay? And unfortunately, I cannot show you the numbers, the exact numbers on the y-axis, but the y-axis is average viewing in the left graph and the average attention on the right panel. Okay? The x-axis in this slide is score difference, and we see kind of inverted U-shape. So the viewing and attention is going to be highest when the score difference is like 1 or 2. Okay? And then it's going to be smaller if the score difference and the one team is going to outscore the other team. So that's kind of natural. But in terms of relationship between innings and attention and viewing, we see that later innings observe higher attention and higher viewing. Okay. All right, so this is about some simple summary statistics. And if there are any questions, I'm happy to take, but otherwise I'm going to move on to the characterization of suspense and surprise. Okay, great. Right, so using this baseball data, we're going to first estimate suspense and surprise. Okay, and how do we estimate suspense and surprise from the data? We're going to closely follow the seminal paper by Ely, Flankel, and Kamenika, JPE 2015. This is a theoretical paper about Bayesian persuasion, but they have an empirical section in which they kind of estimate suspense and surprise for different situations like tennis, presidential elections, and et cetera, et cetera. We closely follow their definition about how to calculate and estimate suspense and surprise. So let me first introduce notation, which is mu GT. In their model, they assume rational Bayesian viewer. So they have rational expectation about the home team winning probability. So MuGT shows the belief about home team winning probability given the all available information at time t. So the viewer is Bayesian rational. Given the all available information, they're going to calculate and estimate what is the probability that home team is going to win this game. Okay, that's MuGT. Okay. And using this MuGT, we can now estimate suspense and surprise. Okay. The suspense is calculated using this formula. This is basically, suspense is basically the standard deviation or variance of how MuGT is going to be in the next period. How uncertain the agent thinks the chance of home team winning is going to change, given the all information available at time t. Okay, so the suspense is the ex ante measure of what's going to happen to the next period, time t plus 1, in terms of MuGT. That's the suspense. And surprise is the simply difference between MuGT and a MuGT plus 1. Okay, so this is the ex post measure of what happened in a game in terms of home team winning probabilities. Okay. So using this suspense and surprise, we can estimate and characterize suspense and surprise. Okay. So to calculate suspense and surprise, we're going to start from estimating MuGT. Like I said, we assume rational Bayesian viewer, so we can estimate the predicted model of home team winning given the all information available at time t. So ST is the state variables that help the viewers to predict what is the probability of home team winning. Okay. The ST in our analysis includes BO. This is a basis loaded and out count. I is inning, the H is head or bottom, and SD is score difference. Okay. Using those state variables at given time t, we can develop a predicted model of home team winning probability. Okay. And that's going to be the MuGT. Okay. We train this predicted model using XGBoost, using all 877 games in 2018. And our prediction accuracy is about 80%, which is, I think, satisfactory, okay, and actually quite robust. We tried different machine learning models to develop these predictive models, and we see.
Okay, can we ask a question?
Yes.
Yeah, so I'm sorry, I understand the model you've written down, but is there some attempt you're going to show us that this is actually a good model of baseball? I mean, you know, a lot of time is spent planning a lineup. So I would have thought, for example, whoever, you know, given these state variables, another really important state variable is going to be who's at bat.
Yeah.
You know, so, I mean, some people hit very infrequently, but hit home runs. Other people never hit home runs, but they're very likely to get someone on base, and all these things kind of interact. And I mean, I understand you want a simple model so that you can fit the, you know, Amir's model to your data, but I'm just trying to figure out why is this the right way to think about people's priors in baseball?
Yeah, I definitely agree. And you know, the state variables we have here, B, O, I, H, S, D, may be too simple. Well, in empirical analysis, we actually include additional controlling variables, including like the batting orders or the cleanup. We are not able to control individual player. Maybe we can do that for like.
Well, so let me rephrase my concern then, because my concern is like all these state variables are probably predictive of whether or not someone's going to keep watching. I mean, if there's nobody on base, this is not as interesting to keep watching as if there's somebody on base. But if you want to give this very stylized structural interpretation that what you're going to have is measuring people's suspense and surprise, and it seems like that's going to be really critical for the structural interpretation. I don't think you can just write down a model and say this is suspense and surprise.
Yeah, I mean, in principle, we can put more variables here, not just these variables, but also any variables that might affect the home team winning probabilities. Yeah, we haven't included those variables in the prediction of these predictive models. But if we estimate a choice models to choose, you know, which action, viewing, attention, which variable to choose, which action to choose, we do incorporate additional game features.
I mean, I understand how this model works when you're applying it to something like casino gambling, where like a slot machine has objective probabilities, and so or even a card game has objective probabilities. But here, this is highly subjective. Like, what is it? I mean, it requires that in order for this to be the right way to think of suspense, there needs to be some evidence that this is how viewers think of how they forecast a victory, and that then the thing that you're measuring a change in variance on is a change in the variance of their beliefs about a victory.
Yeah.
So I'll stop here because you have a limited amount of time, but it just seems a little bit arbitrary. I mean, other than you've stuck some variables in, and then other than you fit a stochastic process, and then you're going to take the variance of that thing and call it viewer suspense, or changes in viewer suspense, but it just feels a little arbitrary. That's all.
Okay, maybe we should discuss more about that, how to justify those variables. But I think how to predict one team is going to win given the information available, like ST. There is a operational research literature looking at modeling this kind of statistical models of baseball games, and those state variables BOIHST, these are coming from the previous literature looking at the baseball game, like kind of the Moneyball papers. But of course, the suspense and surprise, that's kind of more subjective, and we might have to think about more additional features about games to make it more probably realistic. Yeah, so that's step one. So far, our model includes those state variables that have been used in the literature of Moneyball. And then step two, we can also estimate the state transition probabilities from ST to ST plus 1 directly from that data set. Right, so to kind of show some validation of how suspense and surprise move around during the game, I just want to show you a few example games. One is April in 2018, the other is September 2018. The first game on the left panel, this is a kind of boring game. So one team, so this yellow line is the difference in scores. In this game, the away team scores 2 points at the beginning and then 3 additional points in the middle. And after that, basically the away team is always dominating the home team. So therefore, the green line, the predicted probability of home team winning, is always kind of close to 0. The home team is unlikely to win the game anyway. And because nothing happened during the game, suspense and surprise, the blue line and the red line are almost always 0. There are some bumps, but almost always 0. But on the other hand, the right-hand side, this is a more exciting game in the sense that the score difference between the two teams is 0 up until maybe the 9th inning of the game. And in the 9th inning, the home team gets 2 scores and the home team won the game. So therefore, the home team winning probability, this green line, is kind of jumping up and down. And when the home team get 2 scores in 9th inning, the home team winning probability, predicted home team winning probability, goes up and then going to flat. And so therefore, the suspense and surprise, again, the red line and blue line, are kind of moving up and down depending on the change in the home team winning probabilities. And in the 9th inning, when the home team get the 2 scores, the surprise jumps up, and also suspense are kind of going up right before the home team get 2 scores. So, these 2 games are just examples, but I think kind of show some validation about our predicted model captured some suspense and surprise happening during the game. So I'm going to show you again a few descriptive statistics about the relationship between suspense and surprise and game features. So this is a basis loaded and suspense and surprise. So 7 is full basis and 0. So 7 is fully loaded and 0 is nobody on the base. So in terms of suspense, we see increasing patterns. So if more base is loaded, the suspense is going to increase. I think that makes sense. Whereas for surprise, there is no clear relationship between bases loaded and surprise. So surprise is something like home run or things like that. So therefore, we don't really see the clear relationship between bases loaded and surprise. So again, this is some validation about our predictive model, I hope. In terms of score difference, there is a clear relationship, downward sloping curve between the score differences and suspense and surprise. So suspense and surprise are both highest when the score difference is 0, so tie. Okay. This is about the data, and now we combine all pieces together to estimate a choice model. The model we're going to estimate is a multinomial choice model, logit model, so quite simple model. In each minute, an agent, a viewer, is going to decide one of the three options: 0, tuning away from baseball games, or watching other TV programs, or turning off the TV. 1, if the agent is watching but not paying attention. So I'd say this is low attention. Y is equal to 2 if the viewer is watching and also paying attention to the screen. This is a simple multinomial choice model, and as a function of suspense and surprise, commercial, demographics, and other gameplay variables, including cleanups, fans, etc. Well, we kind of debated such a long time whether we should estimate a more kind of structural dynamic model. But for now, I think this simple multinomial choice model is great in terms of, in the sense that we can put more dummy variables, we can allow flexible interactions, etc. So this multinomial choice model fits really well to the data. On top of that, we tested like nested logit model or ordered logit model. We allowed time dependencies, etc. But our qualitative results are kind of robust. Okay, so let me show you first the model without any interactions, and then in the next slide I'm gonna show you the model with interactions. Okay, all right. So here I have two parts: low attention and high attention. The first column 1 and the fifth column 1. These are coming from the same multinomial choice model. So 2 and 2. Second column and sixth column, they are coming from the same multinomial choice model. And in terms of suspense, we find that suspense is always positive and statistically significant. Suspense increases attention. In terms of surprise, it's kind of unstable. For the low attention, y is equal to 1 or viewing. Surprise is sometimes negative, but when we have a game fixed effect, it's going to be insignificant. In terms of high attention, it's not statistically significant, but once you put game fixed effect, it's going to be positive and statistically significant. So I'd say surprise effect is kind of unstable across specifications. In terms of demographics, age is always positive and statistically significant. So older people are more likely to pay attention for both levels of attention. And female women are in general have low attention for both levels. And in terms of commercial, this is, I think, interesting. The commercial, it increases the attention level for the low-level attention. So it's kind of that increases viewing. But in terms of high attention or paying attention to the screen, it is negative and statistically significant. So commercial increases low attention, but it also decreases high attention. So there is a difference between the differential impact of commercial during low-level attention and high-level attention. Yeah, so in terms of post-season and a cleanup, these are positive. Post-season is positive for both levels of attention. Cleanup, yeah, I don't know how to interpret those coefficients, but it's mostly negative and statistically significant. Okay, so that's the model without interaction, and now we're going to talk about the model with interactions to show some interesting interaction effects. Well, again, suspense enters positively, but surprise is not statistically significant.
Sorry to interrupt, but you have 10 minutes left.
Okay, great, thank you. And in terms of gender, female viewers, again, in general, don't pay attention to the screen, and also they don't watch the baseball games. And also they don't really respond to suspense and surprise both. So the interaction terms of suspense and female, surprise and female are both negative and statistically significant. And in terms of age, yeah, older viewers are more likely to respond to suspense, but not to surprise. In a commercial, this is again kind of interesting. Commercial increases low-level attention, but not to the high-level attention. And also in terms of interactions, we find that a suspenseful moment, commercial impact for both level of attention, low level and high level attention, would be increased. Okay, so if the advertisers have commercial during the suspenseful moment, they have more eyeballs. We have more interaction terms. Maybe we're going to focus on something interesting, which is the interaction between commercial and the female. So here I find that interaction between commercial and the female are positive, and the statistical significant for, especially for high-level attention. Because we know the brands of those commercials, we checked what kind of brands are advertising during the baseball telecast. Mostly they're kind of alcohol beers, heavy trucks, or things like that. So arguably speaking, they are targeting to male viewers. That makes sense. But this result shows that actually female paying more attention to commercials during the baseball telecast. So maybe advertisers may want to adjust their targeting strategy towards more female viewers. We have more interaction effects, but let me skip it. Okay. Right. So we have estimated this choice model, and using this choice model, we're going to do some counterfactual simulations to think about some product design. The counterfactual simulations we're going to do is game rule changes. And like I said in the introduction, Major League Baseball is actively talking about possible rule changes in 2020. Some rule changes are actually implemented, some are not. For this analysis, we're going to focus on two rule changes. One is mercy rule, because under this rule, if the game is going to end if one team outscores the other team by, I think 5 points at the end of 7th innings. Okay. And another rule change we're going to implement is shortening the game from 9 innings to 7 innings. Okay. And a key assumption we have to put in this kind of factual is that, yeah, the teams and the baseball teams are not going to change their strategies radically when the game rules are changed. Okay. So we are now endogenizing the strategies taken by the baseball teams. So we have to keep that part exogenous. That's kind of strong assumption, I agree, but we can probably look at the short-term effect of those rule changes. All right. In the counterfactuals, given the model we estimated, we can re-simulate what's going to happen in terms of suspense and surprise. We are showing the two same games that I showed before. We see the same patterns, like in the previous slide, but I think the fluctuations in the counterfactual scenario are much larger than actual games. All right, this is our counterfactual results in terms of shortening the game from 9 innings to 7 innings. And we find that the total viewing to the game is 5.81%. This is the choice probabilities, 5.8% to 5.86%. So that the total viewing time to the game increases a bit, but not much. Okay. But we find the larger increase for the total viewing time to commercials from 678 to 701. Okay. And in terms of low attention and high attention, we find that high engagement attention to commercials, so it is 1.24, increases more than the low-level engagement attention. So 1.18 to 1.24 is bigger than the 5.60 to 5.77 in terms of percentage. Then in terms of mercy rule, we find the kind of similar patterns. We find that total viewing to game increases from 6.42 to 6.5, but we find larger impacts on commercials from 7.16 to 7.36. And again, in terms of high attention and low attention, we find high engagement attention to commercial is larger than the low engagement attention to commercials. In the paper, we have more discussions about the counterfactuals, and we did some calculation, more counterfactual results. But let me wrap up quickly. So in this paper, we investigate the impact of TV program contents on audience engagement, especially viewing and attention. And we measure the program contents using suspense and surprise, but we also include a lot more variables about the TV program contents, and I see the differential impacts of TV program contents on viewing and attention. Okay? And in one particular finding I think interesting is the commercial generally increases viewing, but it decreases attention. So as long as the advertisers are pricing in terms of using the viewing, maybe they are paying much more than actually viewers are paying attention. They're probably overpaying to the commercials. And in terms of rule changes, we find that impact of spillovers. Okay, the rule changes shortening the game, the measurables, both tended to increase attention to commercials much more than the impact on games. So the rule changes to the game has larger implications for commercials. So that's the spillover effect we identified. All right, so this is all I have, and I think I'm still on time. Thank you. Let me stop sharing.
Okay, so shall I share?
Yeah, please.
Okay. So can you see? So can you see the share screen?
Yeah, I see your screen, but it's a file. I'm seeing your folder.
You're seeing my folder?
Yeah.
The area chair.
Weird. Now, what do you see?
No.
Same thing.
Okay, now do you see this the PowerPoint?
No.
No?
No. I'm still seeing your folder.
You're just seeing my folder. Okay. That's weird. Let me see.
It says list of papers I've rejected this year.
Yeah, good catch. All right, you know what? Maybe I should stop sharing first. And
that's a better view, at least.
Thank you. I agree. I'll share again. So how about now?
Yes.
Great.
We can see it. It's good.
Okay. All right. So everyone can see the slides, right?
Yes.
Okay, good. Thank you. All right. So first of all, thank you for having me as discussant for this very interesting paper. And I hope all of you enjoy the interesting talk from Kosuke. So my name is Ted Chen, and I'm a discussant for the paper. Very quickly, I think Kosuke kind of already gave a very clear description about what the paper is about, but just let me quickly summarize. Now, this paper is about how TV program features affect consumer viewing and attention. So in particular, they focus on two features, suspense and surprise. And they also ask, how should a planner design TV content? Okay, so to increase the engagement. I think this is actually a very important question, because as advertiser, we care not just about viewing, but also about whether people pay attention to our commercials. When they think about what should be the alternative design, they use different counterfactuals. One of the counterfactuals is about change of commercial timing, Kosugi didn't have time to talk about that. He did talk about shortening the baseball games from 9 innings to 7 innings, and also using mercy rule. Okay, and they show that their counterfactual policy can actually increase not only viewing but also attention. So this could be very, very valuable to advertisers. And in order to answer the 2 research questions, they use individual data, okay, contain a high frequency logs, and then they can actually use that to measure high or low attention, and then they estimate a multinomial logic model of attention state choice. Okay, so what do I think are the strength of this paper? Okay, so I'm going to pull out 2 photos which Kosugi showed in his talk. So, with this kind of device, okay, so you can, in the past, advertisers also do this. They can see, whether people are viewing the TV or not. Okay, so they also can use the collect second by second data, okay, to see the viewing data. But this paper is really, collect a very cool data set. It is not just about viewing, but about TV engagement. Okay, so they use a facial recognition algorithm. Okay, they can actually tell each member whether they pay attention to the TV screen or not. So this is a second photo which Kosugi also shows, right? So a person, they can have a different algorithm there. You can kind of check, like the facial expression, happy, whether engaged, and so on. Okay, so I think this is really a very cool data set. And I think another strength is their findings. Okay, so they don't just look at viewing, but they also kind of investigate how to attract attention. Okay, how to make sure that people are attentive during the viewing. And finally, I think there are some important managerial implications showing high versus low attention. Because the different states can have different values for managers. And I think they kind of have very interesting results on changing the baseball rules. I never know that there were actually baseball games which only have 7 innings, and I don't know that the mercy rule can also be used. So I think that's interesting. All right. So having said that, now maybe I will discuss some of the potential issues and give suggestions on maybe what can be done. Okay. So I will focus on 3 parts. The first is about data. I really want to see more detail in the paper discussing how the algorithm works. Okay, I try to see, but I think the current discussion is too brief. So for example, here, I want to know, does attention only measure the eyesight? Okay, what if a person has eyes on TV, but this person just talk a lot and laugh a lot? So does it also mean attention, high attention? Okay, and also found from the paper, in figure 1, which is actually this one. Okay, it says that sometimes looking away is unknown. Okay, but at least in the second photo, I saw some of this description. So what if looking away is unknown? How do you treat this observation? So this is something which I like to know more. And I think because the algorithm is actually one part of the strength for your paper, more detailed description will help the paper. And from the data, I also want to know what are the switching probabilities of these attention states. So for example, I want to know from high attention, is it easier to switch to low attention or no viewing? Or it is easier, right, to remain at high attention? Now I ask this question because this is related to my major comment about the modeling, okay, below, which I will show in the next slide. Okay, so now let me turn to the model. So the model is mainly focusing on suspense and surprise. Now, first of all, I want to see more motivation about why you focus on these 2 variables. Now, I think Ali et al., their paper is well known, okay? But in terms of sports, I can easily think about, other factors which can also attract attention. For example, like excitement. If both teams have high scores, then probably, the game would have more excitement, more home runs, okay? Or how about star power and also importance of the game, right? And so why do you choose to focus on suspense and surprise? This is something which I want to see more discussion. Now, another question is about the measure of suspense. Now, it is actually quite curious to me why it is measured in such a way. So to me, if as an audience of a sport game, I care more about which team will win at the end. If that's what I care about, then isn't suspense, a better measure is about, the winning probability of home team is just at 50%, because this means that I have the most, I'm most uncertain about the final outcome. But it seems that your measure of suspense is from this minute to next minute, how things can change. Okay, so I think some justification about the suspense will work. Okay, so the next thing, which I think is probably the biggest issue for me, is about the multinomial logic choice probability. Okay, so one of the implicit assumption, which I think it was acknowledged in the paper, is that for a viewer, even when last minute the viewer is not viewing or pay very low attention, the viewer can still calculate suspense and surprise. Now, that can be a very strong assumption. Okay, I understand that sometimes you need to make assumption for the model, but if you can think about some way to allow that the viewer may not be able to update the suspense and surprise, you may have a better specification. Now, the for me is this multinomial logic model basically assumes that the attention state choice, they are independent across minutes. Okay, so every minute I'm choosing whether I should view, whether I should pay how much attention, high or low attention, every minute. But I'm thinking about state dependence of attention states could be very important in this context. Okay, I'm more thinking about like a psychologist here. Okay, so if I'm highly attentive last minute, okay, maybe the chance that I will continue to be highly attentive will be higher than switching to other states. And that is why I push you guys to check the switching probabilities from the data. Okay, and why I think this is important, because I think from psychology literature, there's a large literature on attention. Some question or comment? Okay, so I think there's a literature on attention or sorry about that. Can you hear me?
Yes, yes.
Okay, I don't know why, maybe suddenly some internet interruption or something. So let me share again. Okay, can you see it? The PowerPoint slide?
Yes, yes.
Okay, thank you, good. Okay, all right, so I'm talking about this, the choice probability model. And, if I think about the dual process theory, right? So this is not just a simple choice model. It is actually about, something like, attention could require cognitive resource, okay? And therefore, I can think about, suspense or surprise may have less impact if an individual already, is depleted of resources. If the person has paid high attention for a long time, then maybe this person will be easier to turn to low attention states. On the other hand, we can also think about attention states can be reinforcing. If I pay high attention last minute, okay, I can follow how the game goes, and therefore it may actually increase my excitement, and therefore it will also increase my current attention. So to me, I think, attention state or inattention is not just a, this independent minute by minute choice. Okay, I would like to see more, you dive deeper to think about, like state dependence, and also incorporate, if you can incorporate some of the psychology literature to justify your specification, that would be very useful. Okay, the last thing I want to comment is about the counterfactuals. The first thing, which to me, the question to me is, how can you measure the economic value? If we don't know what is the value for low attention versus high attention for advertisers. So I don't think we can simply assume that all the value come from high attention. Even sometimes people are not watching commercial, but even if they watch away, but they may still, listening to the commercial, right? That can also affect their awareness and also affects their interests, right? So there can be some value. And so therefore you probably need to think about, what is exactly your assumption when you calculate the economic value. Now, Kazuki has already talked about the assumption of, the team tactics would not change as rules change. But, I think the endogeneity will be a big concern, right? If you think about this, if you shorten the game from 9 innings to 7 innings, and now if a team just left behind by 1 point in the 6th inning, then you may become more risk-taking, right? So I think this is a major limitation. Okay, and I think the last thing I want you to think about is this question: are your model parameters really policy invariant? Okay, so when you change the policy in counterfactuals, for example, you make the game shorter. Now, viewers may become more attentive. And in this case, maybe suspense or surprise, okay, will have a bigger impact on attention. Okay, which means that the model parameters may change when you change the policy. So I suspect that your current model, reduced form model specification, would not be able to capture these potential effects. So here I want you to think carefully about, what you can do, what you can say versus what you cannot say. Okay, but overall, I think this is an interesting, very interesting data and very interesting results. And I learned a lot, from TV advertising during sports. Thank you very much. All right, so
Thank you,
see how that. Let me stop sharing. Okay. So shall we move on for the next talk?
Yeah, I think so.
Yes.
Okay. Hi, everybody. Can you see me and hear me? Okay, good.
Yes.
So let me try sharing my screen. That seems to be a bit of a challenge. So can you guys see this?
Yes.
And now? Is it full screen?
No, it's not.
Oh, it's not. So first of all, sorry, I'm Hema Yoganarasimhan from UW. And I'm sorry, my name says Sandhya Krishnamurthy. That's my daughter's name. And I have no idea how to change it in Microsoft Teams. So, and I obviously also don't have any idea how to start screen sharing in this, but I'll try again. Okay. Does that work?
Yes, can see the screen.
Is it full screen?
No, not full screen.
Why isn't it full screen?
Because maybe you have another monitor and this presentation is up there. I don't know.
So you're not able to see the slides at all?
No, we can see the slides.
But you're seeing the entire presentation and not the play mode?
Yeah, right. Correct.
That is so bizarre. Let me see again. Okay, I'm going to try once more. Is that working?
Yes.
Now it did?
Yeah, I see your screen.
Oh, good. Okay, thank you. Okay, and everybody can hear me as well, I guess, because I can't see anything else on my screen now except my slides. So if anybody has any questions, please just.
I think if you share your monitor instead of just the application, then the full screen will come up. Maybe that's.
Oh, okay. So let me try that. Good idea.
Yeah.
Sorry, everybody, for the little technical glitch. Let me see. Desktop. Okay.
Yeah,
did that work?
Yes, that works.
I still can't see anybody, but that's fine, I guess. So, okay. So just to introduce myself again, I'm Hema Yoganarasimhan from UW. And today I'm going to be talking about the design and evaluation of optimal free trials for SaaS products. So I'd like to begin by thanking the committee for picking this paper and also assigning a very knowledgeable discussant. And as I mentioned earlier, I can't see anybody on the screen except this. So if you have any question, please just speak up and I can, and I can answer the question. But if you're going to type somewhere, I probably won't be able to see it. And this is joint work with Abraham Barsagari, who is one of our students in the PhD program, and Abhishek Pani, who was, at that point in time working with the data partner that we worked with. Okay, so let me begin by giving you a little bit of background about, SaaS products, and some intuition as to why we are working on this. So if you look at the last decade or so, there has been a big shift in how the software industry has functioned. So what used to be that in the software industry, mostly firms used to sell perpetual licenses, which means that if you wanted a software, you went and, bought a license and you had the product forever. That has largely shifted away to what is known as now what we call software as a service industry. So many of the softwares which were previously available for perpetual licenses now are almost exclusively, or sometimes, in both formats, available as cloud-based services. So what you do is you basically get you pay a monthly or an annual fee, and you end up getting access to the software, and you can continue using it as long as you have subscribed to it. MATLAB, for example, has something close to like a $60 or a $70, depending on how you pay it, monthly fee, for which you can access MATLAB, but they also have, the usual older perpetual license. So this is one of the biggest shifts which has happened in the industry. And now this growth, this SaaS market has grown quite a bit, and it's over $200 billion per year in revenue. And it has, it's over 2.5 times of what it used to be 6 to 7 years back. That's good. What is kind of really interesting is that as the software industry has shifted to more of these cloud-based services, how marketing is done has also fundamentally changed. Historically, what was really important is you're basically convincing people to buy this product. So advertising and traditional brand building activities were very, very important. As we have seen this shift towards a service kind of product, we are seeing that other forms of marketing are actually taking precedence. And one of them is what is known as free trial promotions. And that's what this paper is going to be about. So what are free trial promotions? So free trial promotions are basically a new customer acquisition strategy in this industry, which used to not be possible with perpetual licenses, where you give potential consumers time-limited access to the software. And during this time, consumers can download and use the software and see if it fits their needs. And at the end of it, they get to decide whether they want to continue subscribing to this or, they don't want to use it anymore. And if you look at the, what's happening in the industry, one of the interesting things you will see is that the length of the free trial that each, firm adopts is actually quite different. For example, Microsoft 365, they have about 1 month of free trial versus this is Adobe Creative Cloud. They have about 7 days, and Google Suite, they give 14 days. So you see actually quite a bit of variation in how long these free trials are. And there's not so much research, actually there's not really any research on how long these free trials should be. And if you really look at this question, and there has been some theory work which has been done in this area, if you look at this question and think about from a firm's perspective, how long should the trial be, there you can easily make arguments for both long as well as short free trials. So from the perspective of, why would you want to give a longer free trial, let's say, a month or 2 or whatever you think is long? It's going to, you might assume that it's going to lead to better learning. People have more time to, explore the software, learn about it. These are all cloud-based products. So, if people create some content, they're going to store that, and maybe that's going to lead to higher switching back costs. But on the other hand, if you have these long trials, you can also imagine that if people didn't use the product too much, and let's say they didn't actually end up using the software for close to 20 days or 2 weeks or 3 weeks, they might end up inferring that this product is not great for them, and without any lack of urgency, as a result, end up not subscribing. On the other hand, if you think about shorter free trials, first they have lower acquisition costs. You're subsidizing the consumer for a much shorter period of time. There is always these questions about free riding. This is actually one of the main reasons given in the analytical literature for, what might be the downsides of a, free trial. That let's say I have a class project, I just download the software, do it within a week or 2, and actually end up never buying it. So you're subsidizing maybe these type of customers. And on the other, and also you might actually not give enough time for people to learn about the software. So, there are pros and cons to both, and which of these actually, which of these effects actually dominates is not quite clear. And more broadly, you might also think about this trial length as being differentially effective for different type of customers and products. So if you think that learning is somehow important, you might say that, okay, beginners really have never used this product. They know nothing about it. So they need more time to actually, learn about this compared to, let's say, experienced users. Similarly, you might say maybe for more complex products, maybe you need longer trials. So there's also the question of if you're thinking about optimal trial length, what is it that, which works globally for everybody? And is there also some kind of heterogeneity in whether a longer and shorter free trial might work differentially for different type of customers? So that brings us to this question of, yes, if different customers benefit or will respond better to different lengths of free trials, should we be thinking about somehow personalizing this free trial assignment? We think about, there's been a lot of work recently on personalizing many types of marketing interventions. These free trial promotions are another type of marketing interventions. And we can think about this question of, can we assign each consumer a different trial length depending on his or her observed demographic and skill, so as to maximize some measure of reward that the firm might have in mind? At a high level, this idea is similar to third-degree price discrimination, right? Where you're essentially by giving the product free for different lengths of time to different customers, you're essentially charging them different prices over a fixed period of time. However, just giving them different prices is a little more challenging. People might react negatively to that. Whereas what you can actually think about is, by giving these free trial, giving it as a free trial, it might be actually easier to implement. In fact, I think, free trial promotions are one of the things which are most easy to personalize without any adverse reactions from customers. Because if you really think about it, they're zero marginal cost. They're relatively easy to implement at scale, especially for digital services, and you're not going to upset customers too much. But, they might still get somewhat upset, but not to the extent if they got really different prices. So we would think that, practically, it seems like we can actually do this. And that brings us to the question of, is there value to doing so, and how would you do so? And that's kind of what this paper is about. So the two broad things that I will be looking at in this paper is, first, how does trial length affect customer acquisition in the SaaS industry? So how does the length of the trial? I want to be clear here. I'm not asking the question of, does the existence of a free trial or not affect the outcomes? I'm looking at free trials exist. Do longer or shorter ones work better? And in this context, I also want to look at this question of mechanism. We want to understand a little bit more about what is a mechanism through which trial length affects conversions. As I said earlier, there are many different mechanisms which have been thought about and proposed. So we really want to think about what do we find in the data? What do we find support for in the data? And then we want to think about this question of, do users respond differently to different trial lengths based on demographics and skills? And if so, how do we think about personalizing trial lengths across customers? And what are the gains from doing so? And then, was there a question? That's just someone talking? I guess so. Sorry. So who benefits from shorter versus longer trials? So we have this question of who would you want to give shorter trials to, and who would you want to give longer trials to? And then comes this question of, okay, let's say we can actually personalize these free trial assignment policy. And usually they are done to maximize some kind of short-term, you might say short-run measure of reward, let's say conversions or subscriptions. But then how do these policies designed to optimize short-run outcomes do on long-run outcomes of interest to the firm, such as retention and revenue? Or should we, what might be the loss from actually not thinking about it in a more long-run perspective? So, and if so, how would you fix those things? So those are the broad research questions that we want to look at. And let me, highlight the main challenges in terms of, data as well as methods that, we would need to overcome to address this. First, if you really want to think about, how does trial length affect some outcomes of interest, you really need data from a setting where, trial length assignment is exogenous to other variables, which can also affect outcomes, such as maybe demographics. If you also want to say something about the mechanism through which then trial length actually influences conversions, we need to see how consumers are using the software. We need some information or data on usage and activity during the trial period, so then we can make some inferences on how this affects outcomes. So that's from a data perspective. Methodologically, what you'll see is that if you have some number of like X variables, let's say pre-treatment variables, and even a very small number of treatments, what would happen is that if you're really thinking of like searching or designing this policy in a very high dimensional policy space, right? So it's basically you're thinking about this as policy design in high dimensions. So unless and until we are able to put some structure on this policy space, it's going to be hard to search for the optimal policy. So there have been recent papers which combine methods from machine learning as well as causal inference for this purpose, both in marketing and also in economics. But there's really not so much guidance on what are the best methods to do so. And maybe they all give the same answer, or maybe they all give different answers. And if so, what can we take away if we compare them? So that's something. That's one. That's the second challenge. And the third one is we need to kind of think about off-policy evaluation to identify the optimal policy. So when you think about a targeting policy and if you want to evaluate how it works, it's obviously not feasible to go deploy any policy in the field. You can maybe do it for one or two, certainly not for a large number of policies. And we need some metrics for offline policy evaluation. And those metrics needs to be consistent and correct and will give us a good sense of what the reward would be if we were to actually deploy this to some kind of personalized targeting policy. So what are we going to do? So this is a broad approach which will, address some of these, address these challenges and, provide answers to the questions that, we set out, we set out at the beginning. So first, we're going to use data from a large-scale field experiment by a SAS firm that randomized trial lengths, and that, and we are also going to observe usage and post-treatment activity. And using this data, the very first step, very basic, you're just going to look at average treatment effects of different trial lengths and then identify what I call the best uniform policy. So what is the, if you had to just give one trial length to all the customers, what would it be that you would give? And then spend some time understanding the mechanism through which trial length seems to affect outcomes. And then I'm going to adopt a two-step framework for policy design and then evaluate it. To design the policies, we are going to use a model of outcomes as a function of pre-treatment variables and the treatment, and then use that to assign optimal trials. There are other ways to do that as well, and I'll talk about that when we get there. And we're going to use an IPS rewards estimator, which is basically an inverse propensity score reward estimator, to evaluate these. And I'll talk about all of this in greater detail, but this is the overview of the approach. Okay, let me tell you a little bit about the setting. The data comes from a large SaaS firm which sells a suite of software products. Think of it as something like Microsoft Office. It's not Microsoft, but something like that, as a bunch of different soft products within one suite. And the firm is actually the major player in the industry. They don't have too much competition. And at the time of the study, they had a default trial length of about 30 days. And then the firm really wanted to spend some time to understand, what was the effect, what was the right trial length that they should be assigning to customers. So they ran a large-scale field experiment with over 300,000 users from multiple countries. And they picked the three most common trial lengths, which were common in the industry, which is 7 days, 14 days, and 30 days. And whenever you think of running these kind of experiments, one issue often is compliance, which is that people might simply choose not to get the treatment that you want to give them. But this experiment was well designed and well implemented, so that actually people came in, they downloaded the software, and only after they downloaded and started their free trial, they were told whether they were in 7, 14, or 30-day condition. So it wasn't and that gets logged rather than you not actually seeing people who looked at 30 days and didn't even bother to download it, let's say. So that was good. In terms of data, what do we have? So we have data on outcome variables of interest, both short run and long run. There is subscription length, and revenues. We also see, obviously, the treatment which the people got, which is 7 days, 14 days, or 13 days of trial. We see 6 pre-treatment demographic variables. The sign-up channel, which means whether you came through some kind of an app or website and so on. The business segment, job, the operating system, country, and skill, which is a self-reported variable as to whether you're a beginner, whether you have more expertise, and so on. And we also see, as I mentioned earlier, post-treatment behavioral variables, which is usage and activity during the trial period. Okay, so that was some background, about the setting and the data and the research questions. Let me start now. Let me now, show you a little bit of the empirical analysis, and then we'll move on to, the personalized policy design. Okay, so the first thing, obviously, that we want to do is, simply basically look at average treatment effect. Just compare the table of outcomes for all 3 treatments. And what we find here is that the 7-day trial actually is the best, and it had over a 5.59% gain over the baseline of 30-day trial. So what this says is that, even by simply giving the 7-day treatment to everybody, the firm can actually do much better. There was a positive effect of the 14-day condition, but it wasn't no way significant, at the, so that doesn't seem to have a big effect. So this is good. At the same time, it kind of gives, gets us to this question of why do shorter trials do better? Why is it that the 7-day trial is better? And at the first glance, certainly for the firm and for us as well, this was surprising for many reasons. The first is that this was, 30 days was the baseline at the time of the experiment. And this is a relatively complicated software with many products and functionalities. So in principle, we would think that more time should help consumers understand the software better and thus lead to better outcomes. Yeah. And if you really look at the theory literature on free trials, most of the reasons actually support the, longer trials would actually say that, longer trials would be more effective. Things like switching costs, consumer learning, software complexity, signaling, all of these kind of suggest that, longer trials should be better, but we actually find the opposite. So it's worthwhile digging a little bit more to see what might be the mechanisms at play. So this is just like a little picture for us to think about, how does trial length affect subscription? So you might say that trial length changes how consumers interact with the software, download and use it, and which in turn can affect subscription. So what we particularly find is that there are 2 opposing effects of trial length. So what you see here is as you increase the trial length, what we find is that if you just look at the top of the, the top part of this picture, what we find is that as you increase trial length, we see more usage. And this is because it's actually an experiment. This is causal, right? So we know that as we increase usage, everything else, trial length, everything else being constant, we see higher usage. And then we see that higher usage is associated with higher subscription. Now this is an association. It's not necessarily causal. On the other hand, we find that when you give longer trial lengths, so that part is all good. More you give a longer trial, people use it more, and that seems to be associated with higher subscription. On the other hand, we also find that when you give a longer trial, we find a big gap, larger gaps between when people last use the product and when they have to make the decision to subscribe or not. And in general, the average number of active days and activity per day kind of reduces. So what's not happening is that people are not scaling up the usage so much. And this gap, this like big gap between the last time you use the software and when you have to actually subscribe, seems to be associated with lower subscription. So what we see is that both these effects exist. Like on one hand, you see that, people are using it more. At the same time, you see these like big periods of inactivity at the end of it. And that might simply be leading people to conclude that this product. Let's say I actually have a 1 month trial. I didn't use it. I just used it for 4 days. And then, at day 30, I have to decide whether, I download it or not. I might simply decide that, hey, I haven't used it for the last 3 weeks. I don't think it's so useful, and I don't actually get it. But if it was 7 days, I probably, end up actually getting it. So these are two different effects, and we find that the latter effect dominates. And for those of you who are wondering why I don't have tables and numbers here, that's all in the paper. For those of you who are interested, I just wanted to put the summary here rather than have many different tables. Okay, so this is at the global level. What we're going to now do is think about, okay, on average, these effects seem to be at play. How about personalizing this and thinking about if you actually gave different people different trial lengths, how would this vary, and who would be the people who would get a shorter versus a longer trial. So before I actually spend a lot of time developing a personalized policy, it's useful to just kind of look at the data and see if there is anything in the data which supports this idea that personalization might help. And this is just one simple graph where we have partitioned users based on their skill level and then plotted which trial length is better for whom. And what you can see, for instance, here is that actually beginners respond better to shorter trials, versus people with mixed skills seem to respond better to like the 14-day trial. So we do see some heterogeneity in how people are responding to trial length based on, for instance, skill. And this is also true for other demographic variables. I'm just showing you, one snapshot of the data. So given that there seems to be there is some suggestion that there might be benefits to personalization, we want to now think about how we would do this. So I'm just going to, I'm sharing this high-level view of like this optimal policy design problem. So when you think about a personalized treatment assignment policy, what you're really thinking about is a mapping between users and treatment such that each user with some pre-treatment attributes X is assigned some, treatment W. And the firm's objective here is to maximize some reward function Y, right? This expectation of this reward Y, which is a function of their pre-treatment variables and the treatment that pi that they would get given this policy. So pi here is going to refer to some targeting policy. Obviously, you can imagine that as the cardinality of X and W increases, the number of personalized policies is just going to be really huge. And the goal here is to find this optimal personalized policy which maximizes this reward. So if you think about this, searching for this optimal policy, if you really thought about it from an unstructured perspective, this is a very, this is a search over, a very, very large policy space without imposing any assumptions is going to be problematic for two reasons. One is that, how do you even go about it? Second is that you'll simply not have enough data in each region of this policy space to act in a finite sample setting to actually make any meaningful inference. So what we usually do is you want to kind of put some kind of structure on how, outcomes or treatment effects are affected by treatment variables and the treatments, and then use that to design policy. And there are two broad ways to do it. There are other ways as well, but the two broad ways to do it are using outcome estimates as well or heterogeneous treatment effects. So in the first case, both are, both work. There is nothing wrong with either of them. They are just making different, you might say parametric or semi-parametric assumptions about how, I would say how outcomes or treatment effects are affected by the X variables. So in the first case, you're using, we are designing policy using outcome estimates. So you would, basically model that as some f of X, and then use that to assign the optimal policy based on, whichever treatment then actually maximizes the outcome of interest. In the heterogeneous treatment effects case, you actually get these, pairwise gates, and then you'll use that to assign policy. What I'm going to do in the main text of the paper and for the talk is to focus on one outcome estimator, and then we'll compare it with like other possible methods at the end of the talk. And the method that I'm going to use is a lasso. It's basically a regularized regression to penalize model complexity, right? And where lambda is going to be learned from the data using, cross-validation. But as I said, there are other options, which I'll show you the results for later. I think you could, instead of, lasso, you could use a linear regression or a cart or random forest or XGBoost or anything, which you like. And for heterogeneous treatment effects estimators, I'm going to use the two which are increasingly popular in marketing, causal tree and causal forest, and show you their performance as well. So now we are at the third step, which is policy evaluation. So how do we evaluate policy? So any targeting policy. This is just a little picture which I find helpful to help you think about policy evaluation. So these purple boxes that you see here are what I call policy congruent observations. So on the x-axis, think about your entire data. What was the actual treatment people in your data got. So those are just your treatment buckets. That's the rows that we have here. And the columns are for any policy that you come up with. You can think about what is, you can actually assign them into different buckets again, depending on the policy. And then you will have some people, right? If the assignment was random, if there is coverage, you should have some people who actually got the treatment that your policy says they should get in the data. Intuitively, if you can scale these people up, you basically have a measure of how your policy would do if it was actually given to everybody. So what we are really trying to do is take these purple boxes and then impute them on the white boxes. And this IPS estimator is pretty commonly used in the RL and counterfactual policy evaluation literature in both computer science as well as statistics and in many fields. And it's not really new. It has been around since Horwitz and Thompson from 1952. And it was later repopularized in the Dudek et al. Paper. But really, all we are doing is creating a pseudo population of people who receive the policy prescribed treatment and scaling them up by the propensity of receiving that treatment. It's basically very simple. And this gives you a measure of how well your policy would do if you gave it to everybody. Okay, so that's the basic framework. Let me start showing you some results. Okay, so the first thing I want to show you is if we went ahead and actually implemented a policy based on lasso, what would be a personalized policy based on lasso? What would be the gains from doing so? And this is a table which shows that. You can see that, what this policy does is actually it's not in the table, but I'm just showing you the numbers here. What this policy does is for 70% of the users, it gives 70 days. And for about 20% of the users, it assigns 14 days, and about 10% of the users, it assigns 30 days. And this policy, this is this personalized policy, we see that its gain in subscription is about 6.81%, compared to the baseline, which is 30 days for all. And this number is higher than the 5.59, which was the base uniform policy. So we see that personalization does help, but we also see, which I have seen in my other papers and Omid's other papers as well, that in general we always generally find that personalization helps, but not insanely so, which is reasonable because we are talking about marketing interventions which can substantially shift outcomes, and any insane number should make us suspicious, but we see that there are moderate gains from personalization. Okay, so that was, we see that, okay, personalization helps. Now it's useful to think about segmentation in this personalized policy, right? We saw that this policy gives different treatments to different type of users. Now can we think about, can we correlate users' optimal treatment with their pre-treatment demographic variables and post-treatment behavioral and usage data? And why do we want to do that? There are two good reasons to do it. First is that it gives us a little more evidence for the underlying mechanisms that we touched upon earlier. And if we have a sense of who responds to what kind of trial lengths well, in principle, any findings here can be extrapolated to other settings and other type of promotion. So this is more from, what can we take away more generally rather than more specific to this setting. Again, I'm not going to show you the details of the tables and so on, but just the main takeaways. So what I do here is essentially show you the effect of within each segment. What are the demographics which are more prominent compared to the population? Then we are going to look at the effect of longer trials on usage, the effect of usage on subscription, and the effect of longer trials on decision gap, and the effect of that again on subscription. And what we find is that 7-day optimal people, again, they're different on many dimensions, but one main dimension in which they're really different is most of them they're predominantly beginners and they are low skilled. And for them, we see that actually when you give them longer trials, yes, their usage scales up, and the scaled up usage has a sufficiently high effect on subscription. At the same time, these are also the people, when you give them longer trials, they go through long periods of inactivity at the end of the trial. This gap between when they stop using the product and when they make the decision is high. And the effect of this gap on subscription is also high, which is not good. So that's why, yes, they end up using it a bit more, but there's such a huge negative effect of this gap in usage that it's optimal to give them 7-day trials. Whereas the 14-day optimal people we see are people for whom mixed, they're mostly people with mixed skills. It seems like they are the people who are actually learning and using the software the most. When given longer trials, they tend to use it much longer. The effect of usage, but the effect of usage on subscription is kind of low for them. It's positive, but it's not, the magnitude is smaller. And that could be because they're still figuring out whether whether the product is a good fit for them or not. And maybe even, as some of them use it, they probably figure out it's not so, it's not so useful and choose not to subscribe. And at the same time, we also find that the negative effect of longer trials on decision gaps is relatively small. And the effect of that on subscription is, kind of average. So you can see that they kind of scale up the usage. There is some medium effect of this gap. So they kind of fall somewhere in between. Whereas if you look at these 30-day optimal people, we see that there is a big, for them, there is a positive effect of longer trials on usage. And this translates to also more positive, subscriptions. But these are also the people for whom we don't see so much negative effect of this gap of not using the product. And these are people who are more likely to be experienced, or what we call legacy users, who probably had the perpetual license version of the product. And it's understandable that they are less likely to make a negative inference about the product, even if they haven't used it, because if they're already experienced with the product and they've used it in other settings, they might, even if they didn't use the software version for, let's say, 2-3 weeks, they're less likely to infer that it's useless. So this
Sorry
is
to interrupt, but just wanted to mention that 10 minutes is left.
10 minutes? Okay. I should be fine. Thank you. So what are some of the key takeaways from the segmentation? First, we find that the right trial length for each user really depends on how their usage and decision gap evolves with trial length and its effect on subscription. So really, different people seem to react differentially to trial length and how they use the product and interact with it, and how that usage again affects subscription. And that seems to be the main driver for who benefits from longer trials versus shorter trials. And this, as I said, there is some previous analytical work in this on this topic, and we are able to say something. We are able to add something to the literature in terms of whether we can confirm or disprove some of the existing theories. So the first is that our results certainly confirm this idea that longer trials or free trials have a positive effect on usage and learning, which has a positive effect on subscription, both on average and even within segments. That's certainly true. Interestingly, it also disproves this idea that there is free riding happening. People who use more actually also tend to subscribe more. We see that in the data, right? Because if free riding was happening, we should see that people who use more actually end up not subscribing because they ended up using it, they kind of have free riding, and now they don't want to use it. That doesn't happen. There's also a new idea which has not been explored so much previously, right, in the literature, and this idea that when you give long trials to people and there's no urgency to subscribe, they end up waiting and not using the product. And when they have this big gap in usage, they end up not subscribing as a result. And together, these three results lead to this kind of counterintuitive finding that for beginners and low-skilled users, actually you should get shorter trials versus more, because they are the people who actually end up, especially for more complicated products, they actually end up not using the product so much, and they end up having these long gaps of non-usage, and there is really no free riding happening. So the main takeaway, apart from what we see here for this specific paper, is that in general, from a software firm's perspective, you want to give longer trials if the product is easy to use and consumers are skilled, because that will scale up the usage, increase stickiness, and learning. But if people can't use the software too much, for people who can't use it too much, even with longer trials, they should get shorter trials so they don't infer that it's useless. Okay, so that was about segmentation, and so far everything that we have talked about and the policy that we designed is everything to do with short-term outcomes. Now you might want to ask, okay, what about long-term outcomes? And it's again important to evaluate the policy on long-term outcomes. Because you might imagine that if you bring in users, for example, if your goal is to maximize subscription, you might actually end up with a policy which, let's say, leads people to subscribe to cheaper bundles or more educational discounts, and or people who are less loyal, which kind of trades off long-run variables, outcome variables, with the short-run variables. But what we find, we want to get there. So what we do is we evaluate, again, the same IPS evaluation of these policy that we came up on the long run outcome variables. And I find that both customer retention and profitability are actually, for the personalized policy, are still positive and still higher than the other uniform policies. But so that's good. So we see that we actually do pretty well, and there are pretty good gains from using this policy optimized on short-run outcomes on long-run outcomes. But you might kind of ask this question, but what about directly optimizing on revenues or subscription length and retention? So before we get into whether we can do this or not, which we will, but I want to say that from a firm's perspective, it's a highly impractical thing to do, because if you are looking at like 2 years of like revenue data or retention data, you're not going to wait 2 years to kind of come up with this personalized policy. So that's one thing. And the second thing which I noticed in the data is that these other outcomes like revenues or retention are pretty high variance outcomes, and unlike subscription, which is binary. So anytime you design a policy on that, there's going to be more noise, so the policy's performance is going to suffer more. And what we find is that in this setting, and I think that's probably true for most marketing interventions, is that there is no big difference in the loyalty and profitability of customers as a function of the channel through which they kind of converted. So this is a key thing. If somehow the channel of conversion also affects revenues and retention significantly, that's going to mess up this calculation. But otherwise, what we actually find is that personalized targeting policies optimized for short-run outcomes actually do better than policies which were optimized for long-run outcomes. And that, I think, is simply because we don't, because of two reasons. One is this like variance in the long-run outcomes, and also we have some more data missing for the long-run outcomes, which might reduce the policies like overall accuracy. But that's overall good news, which means that firms can actually develop targeting policies optimize short-run outcomes and be reasonably confident that long-run outcomes are getting optimized as well. Okay, so far everything that I talked about was mostly, was actually with lasso. So the question is, that is just one method to do that, right? How about other ways to personalize policies? You can come up, as I said, there are many ways to do this. So what I'm showing you here is other personalized policies based on different estimators. And the first thing, and what you see in this table here is each policy. So for example, Pi7 is a policy which gives 7 days to everybody. Pi-reg is a policy based on regression, which a personalized policy based on regression and how many people it assigns to 7 days, 14 days, and 30 days. The first mind-blowing thing about this table is that every method is substantially different in terms of how it assigns treatments across, people. And this is, I think, both surprising and in some ways worrisome, right? Because what it says is that the actual method that you use to develop your personalized policy is going to significantly affect the outcomes. And you can see that some methods like CART and causal tree are actually unable to personalize treatment at all. They actually just give 7 days for all. And we see that policies based on lasso and XGBoost actually are largely similar. Regression and random forest are much more dispersed, and causal forest again is not able to personalize as much. So now let's, this is how they assign policy. Let's look at the gains from these alternative policies. At the very top, I have the policy based on lasso, which is what we used in the paper, but I'm showing you now the alternative personalized policies. What you see here is that the policy based on lasso is actually the best, which you might find surprising because lasso is a really simple model and there were much more complicated models in there. And we find that XGBoost does the second best. And what is really interesting here is that policies based on treatment effect estimators like causal tree and causal forest actually perform pretty poorly. I think that's, I'll talk about why this happens in the next slide, but I think that's an important thing because we see a lot more marketing papers now using these methods to gain treatment effects, and then they often talk about some targeting based on that. What these results are saying is that designing targeting policies based on these methods is largely problematic and probably not worth it in most cases. And you can also see that policies based on regression and random forest, which actually, if you look at the paper, you'll see that they're pretty good in terms of model fit, actually, especially random forest, can actually do worse than the best uniform policy. So actually you can, so maybe I feel that one of the main lessons to take away from here is that estimating Kate is not the same as assigning policy. Second, you might actually do much worse with personalization than just going with uniform policy if you haven't done it correctly and done it well, and especially thought about evaluating using something like IPS on a test data set. And we see a lot more papers simply trying to do that. So I think that this is, I would think of this as a cautionary tale. So now, this is my last main slide. It's useful to think about why is it that, these policies differ so much, and can we have some intuition on why this is happening? Because if you think about it from a theoretical perspective, if you had infinite data and fully flexible model, there is only one optimal policy. Why are we getting different optimal policies, and why are they behaving so differently? So what I see here is that what we find here, this picture is not great because all these gray lines look similar. But if eyesight is very good and you're looking very carefully, what you'll find is that CART, causal tree, and causal forest, those are these three verticalish lines in the middle, show very little heterogeneity. So they are unable to personalize the policy sufficiently. So if you really, because all of these are making bias variance trade-offs in how flexible these functional forms are, right, on predicting outcomes of treatment effects. What this is suggesting is they're basically suffering from underfitting problems. They're not flexible enough for whatever reason. Whereas regression and random forest, you can see have the maximum heterogeneity. So what they're really doing is they're inferring more spurious heterogeneity than there is. So it's kind of more of an overfitting problem. So when it goes to the test data, basically there is not as much heterogeneity as it seems to think there is. Lasso and also XGBoost, which are these two things, lines in the middle, actually they seem to have the right balance, where they're able to personalize sufficiently without inferring too much spurious heterogeneity. And that's why we see that they actually perform well in policy design. Okay, so I think I'm pretty much out of time. To quickly conclude, today, the goal today was to think about how would we optimally design free trial promotions for basically SaaS products, especially, and this is important because this is one of the main ways in which this industry acquires customers now. It's one of their key customer acquisition strategies. And substantively, what we showed here is that even though there are a lot of theoretical reasons why longer trials often should work better, we actually find that shorter trials are better for both short-run conversions and long-run profitability. And on average, and we present some evidence for the mechanism at play. And methodologically, we kind of showed you a basic framework to think about designing and evaluating personalized targeting strategies. And also showed you some comparisons on the efficacy of different types of estimators for this task. And hopefully you learned something new, and it was even though I couldn't see people's faces, which helps me gauge how it went. I'll stop now and turn it over to the discussant.
Okay, let me start sharing my screen.
Let me close mine. I don't think I closed mine, did I?
No, just click on that cross.
Yeah, that's what I'm trying to do.
I think that's it, probably.
Oh, I want to do this.
Okay, now looks like I have the same situation. I cannot see many people.
Okay. Can somebody stop my screen sharing, or did it stop?
You stopped. I think I'm sharing it now.
Okay, sounds good.
I think my screen should be up in front of you.
Yes, I can see it. Thank you.
Yeah. Okay, so I had the pleasure of reading this paper, Design and Evaluation of Optimal Free Trials. And this is actually an interesting paper. Honestly, I don't know all these methodologies, but the paper is written so well that it was very easy to follow. I didn't have to refer to many texts. I could just read through the paper. The paper describes step by step how it actually constructs the variables, what are the underlying assumptions, how it goes about estimating. And most of the sentences are very short, simple, sweet. So the paper is very easy to read, very well structured. So I really enjoyed reading the paper. And the paper is actually in a very important area, which is software sampling. The software sampling actually has many strategies involved. You can use time-limited trials, which is considered in this paper. And there are other things like freemiums, version 2 upgrade, seeding, and so on. This paper is in the area of time-limited free trials. And this area is very important because it's one of the most common forms of software sampling. This is what you most often see, time-limited trials, like 7-day, 14-day, or 30-day trials. Now, what are some of the key contributions of this paper? There are actually many contributions. I worked on these trials, not a lot, but a little bit. I worked on this area, theoretical papers. But I think there are a lot of contributions in this empirical paper. So first of all, this has a very nice randomized experiment, and to see whether longer trials are actually beneficial. As Emma already mentioned, that theoretically people think longer trials are beneficial because they offer more opportunities to inform the consumers. But some other people argue, even I also argued, that shorter trials cannibalize the product less, so or you can say less free riding, and in that sense, shorter trials could be better. So there is no really right or wrong answer in theory papers, but in this paper you can see a much more clear answer. You can see that actually the 7-day trial significantly outperforms 14-day and 30-day trials, and this is very important because these are the most commonly considered trial lengths in the industry, and the treatments are completely exogenous. So this result is very powerful here. And then I really enjoyed the excellent analysis of various policies, including how to personalize the trial length, which he talked about at detail. So normally one would expect benefits of personalization to be huge. I really liked that even the uniform policy, which gives the same trial to everyone, does quite well. That was also very interesting to me. And interestingly, they also do well in the long run. And it was interesting because, it tells basically the managers that, just get the trial length right. That's probably the most important thing to you. You don't have to worry about all kinds of complexities in most situations. So I thought that was also very nice. And there are, of course, contributions with respect to mechanism. That's also, people talk about mechanisms in theory papers, but you don't know which mechanism is actually in play. As I said, people think longer trials ought to mean more cannibalization, and that's why they could be bad. But here, actually, the authors rule that out empirically. And the way they do it is actually very reasonable. This cannibalization or free riding, whatever you call it, the authors rule it out, and which is very interesting because I was under the impression that this is actually a major issue. But as it turns out that at least in the context of this kind of products, it is not. And I think that is very important to note. This is one case where the data shows something you would not be able to speculate from the theory correctly. So this is very nice. And then they also offer another explanation, which is decision gap, which could be driving the, which could be making longer trials unappealing. The decision gap is basically the last day you use the trial, and from that time, the end of the trial, that period of inactivity is basically the decision gap. And longer the decision gap, as it turns out that the trial is going to less likely to lead to a subscription. So I didn't know much about decision gap, but given that the data shows that this could be an issue, I think this is also very interesting. So these are some of the key contributions. And in fact, the paper is so well written. There are so many robustness checks, so many discussions. It's very hard to find areas of improvement. So I tried to think really hard and see if I could find anything. I think the area I could find is probably the mechanism part. But given the paper is already so big, I don't think you can probably do this in one paper. But maybe you can think of doing a follow-up paper where you can dig more deeper into the mechanism part. So I just took one random sentence out of the paper, but just to make my point. But there are many other sentences which are similar. So for example, why decision gap? The idea of decision gap makes sense. The paper says this is understandable because a user who has not used the software for a long time, by the end of a trial period, is likely to forget about it and not to conclude that the product is not useful. And this is indeed possible. This is indeed possible. I never thought of it, but this is indeed possible, and the data and the empirical evidence is consistent with it. So the only complaint I have about this is that this could be true, and she mentioned this. Hema mentioned this during the presentation about this point. She alluded to this though very quickly, that this explanation would be true if decision gap were to be exogenous in this setup. Here the treatments are exogenous, so the first part of the work is completely bulletproof, but the decision gap is not exogenous. It's probably not, because a consumer may stop trying a product if she has already gotten all the information he or she needed, and then concluded that the product was not a fit for him or her. So in that case, the consumer might just stop using the product halfway through the trial, and that would lead to a big decision gap. So the decision gap is associated with lower subscription rate, but we still do not know this causality aspect of it. So that part is not resolved. Now, of course, you cannot resolve everything from one experiment. So I understand that part. So it's not really that way a criticism, because you cannot run these experiments any way you want or as often as you want. It takes a lot of time, and it involves a lot of people, real people. So I think there are two possible options on how to clear the issue. And one possible option is, both are same in some sense, that use some theory where the data falls short. You can use some theory to, enhance your interpretations of your results. So one could be theories on consumer psychology. I don't know much about those, consumer psychology, but I know there is a huge literature in marketing. There are several journals that publish a lot of papers. From there, you can develop testable hypotheses. In fact, your explanation actually hints at some consumer behavior. So you can probably draw from some behavioral theories and come out with some hypothesis or a framework, maybe a set of hypotheses linked to what I call boxes and arrows. You can come up with a framework and you can then test it out. If you do that, then with the same data, you may be able to, come up with better interpretations. That is one possibility. The other possibility is actually what Hema is really good at. I know that the structural economic model, she's an expert in that structural economic modeling. Probably she can model that consumers may differ on how much time they need to evaluate the product. They may stop using the product when they have concluded that the product is not a fit and they have no further interest in it. She can probably model all of this in an economic model and then use the structural model to actually estimate the result. And that would also, from the same data, then it may be possible to draw, better, from same data, you'll be able to say more about the mechanism. So that's basically my only thing I could think of when I read the paper, that the mechanism part could be probably better described. But the paper already has so much, I don't know, you can do it in one paper. It's already huge. So maybe you have to do it in another paper. So overall, it's very well done. And I will repeat this point, it's very well written. I mean, I'm not used to reading, this kind of machine learning or whatever papers, especially with, all kinds of variables, and, there is variables that are before, the treatment, pre-treatment, and post-treatment, and whatever after, there are all kinds of variables. But she describes them, lays out everything very, very nicely, and every finding is very clearly explained. So it was a really very fun to read. The paper was very fun to read. I think the paper has important implications for marketing, IS, and economics, particularly economics of experience goods. And she already hinted at the last point I have on my slide, which is that, I think she can even stress the generalizability aspect. She has a lot of data. So I think maybe she can say a few more. I think these are, although done in the context of SaaS products, some of the results probably apply to other cases also. For example, online media subscription to Wall Street Journal online, maybe in that case also some of the results will carry over. Now, it's very difficult to say from one experiment, but I think she may still be able to speculate a little bit more in which context the results would carry over more likely and which context they wouldn't carry over. I think that would probably also broaden the appeal of the paper. So that's basically all I had to say, and I think I'm out of time also. So thank you for a wonderful, wonderful presentation.
Thanks, Hema.
I think I can stop this.
Hi, Atino. Just wanted to say thank you for the comments. That was very useful.
Yeah, thank you. It was a nice paper.
Thank you.
Thank you, everybody, for attending today. Now I have to go away to teach. So I will say good night on behalf of him and the department here. And
hey, Kelly, I just joined, so I'm here. So
okay, hi, Nanda. Then you can take over the speech.
No, there's no speech. So I'll see you all tomorrow. So tomorrow we are starting at 10 o'clock. So I look forward to seeing all of you here. For those of you here, Kelly and I have instructed the timekeepers to basically reach out to the speakers as well as the discussants, so that in case you have trouble, sharing your screen, we can avoid delays. So if you could, they'll reach out to you, but if you can, please send your presentations to them, so that in the event you have any difficulty screen sharing, then they can help you out. Thank you.